Hello, friends. This is Mike from Right Minded, and I'm trying something new. We're doing chill SATs with Chill Mike. I'm just gonna chilly work through some SAT sections, being all chill. We're not gonna be in like a time rush or anything. I'll talk you through my thought processes as I go through each question, maybe approach different questions in different ways. I might make mistakes because I haven't seen many of these questions in a while, and I won't have the answers in front of me. So you might can see some insider process. I'll try a certain way and it won't work and whatever. Before I get started, I'll just say feel free to pause the video and rewatch portions that were confusing for you. Skip around. I'll leave some notes down in the description as to where each question is in terms of timestamps. And ask questions in the comments or email me or whatever. All right, well, let's just get started in a very chill way. All right, here we go. Right, so this is SAT 13 for my students. This is the April 2018 test. All right, so the math section, this is the math no calculator section. We're not going to use a calculator. Here's all the formulas. We're just going to go straight to question one. All right, I'm going to zoom in. All right, according to the system of equation above, what is the value of x? So this is a systems of equations question. Almost all of these questions can be done with the addition or subtraction method, where you just straight up find the variable that you want to cancel out and either add or subtract the equations from each other, both sides, to cancel out. So this one, for example, we just want to subtract this entire ass equation. I'll do this in a different color. We're subtracting this whole ass equation, both sides, from this whole ass equation. The thing to keep in mind when you're doing this is that if you're subtracting this whole thing, you need to like subtract the x, but then you also need to like subtract this one. You need to subtract the y too, and you need to subtract this, which basically means like even though this y minus 2y, it looks like you would go y minus 2y and that's negative y. That's an easy way to fuck this up. You're really subtracting negative 2y. It's y minus negative 2y. So it's actually y plus 2y, so it's 3y. So that's the easy way to mess up a problem like this, but as long as you don't fall for that mistake, we are subtracting both sides. The reason why is because x minus x is 0. This x is going to cancel. And then we've got y, plus minus 2y, right? It's like minus 2y. So this is plus 3y equals, and then 21 minus 3 is 24. And then, so that's 3y equals 24, and then we're just going to divide 24 by 3 in our dope-ass heads, and that's 8. Easy way to get this problem wrong is just to say b, but they're not asking for y, they're asking for x. This is like maybe the main way that I screw up questions like this, actually. It's probably the most common mistake I ever make. So yeah, so y is 8, but they're not asking for y, they're asking for x. So now we just need to plug y into either of these equations. I like this one because it's prettier. We got x plus y equals 21, and then it's just x plus 8 is 21. It's just freaking 21 minus 8, and that's 13. So, C is the answer. Let me check. Hey, I got it right. Cool. Definitely a main way to get this wrong is to, either do this wrong or to answer for the wrong thing. So almost all these questions work like this, where you can find one of the variables to just cancel out through the subtraction method. But the other way of doing it, if you don't fully know how to do that, is to do the substitution method, where you try to aim to get one variable alone on both sides, or on one side of the equation in both equations, and then set them equal to each other. So just real quick, just to show you, I guess I'll do this in purple. We've got these two equations, right? X plus y equals 21, and we've got x minus 2y equals negative 3. This is going to be slower, warning, but it's going to work. So I'm going to try to isolate x. I'm just going to try to get x alone. Here I'm going to do it by moving y over. We're going to subtract y from both sides. So it's just x equals 21 minus y. That's moving y over. Now x is alone, so that's good. We're going to get x alone here too. Oh, this is actually pretty easy. We're going to move this 2y over, this negative 2y over. So it's x equals, this is going to be a positive 2y minus 2y, and plus 2y to both sides. This is 2y minus 3. Now we've got x alone on both sides, so we can just set both of these equations equal to each other because this x is the same as this x, at least in our solution. So, okay, so it's 21 minus y equals 2y minus 3. And now we're just going to solve for y. So I'm going to add y to both sides over here. I'm going to take this y and move it over here. I'll do this one step at a time. So this is 3y. That's what happened here. And then I'll take this 3 and move it over here. We're going to add 3 to both sides because this is a negative 3. We're adding 3 to both sides. So this is, oh, hey, look at that. This is convenient. It's 24. And then from there, it's the same shit. You know, y is 8. Don't fuck it up. Plug it in. Get 13. All right. Cool. Question 2. Which of the following is the graph of the equation of y equals 2 in the xy plane? So this question is giving us an equation that looks like this. This is the equation. And it's telling us to recognize the graph. So there's two main things to look for in equations that sort of like tell the story of what the graph's going to look like. The first is this, the y-intercept. This part, the b in the y equals mx plus b, just tells us where the graph is going to smack against the y-axis right here. So maybe I'll just point this out, actually. I'll just do orange. Here, boom. This says that our graph needs to hit the y-intercept. It needs to hit the y-axis at -2. So A is wrong because of that. A hits the y-axis at 0. How about B? Well, B is solid from that perspective. It hits the y-axis at the right place. This is -1, -2. Well, how about C? Oh, C is bad too, right? Well, because it's -1, -2, -3. Oh my God, don't fuck that up. How do you fuck that up? It's because you're just going too fast. That's probably how you fuck this up, is you're like, oh, that's like negative. Oh, and this is bad too, because this is +2, not -2. So, wow, we didn't even need to think about the slope, and that just got us to the right answer. Let's just make sure that's the case. B is right, B is right. All right, cool. Just for, completeness sake, though, the other thing that matters is the slope. And the slope, we'll do this in purple, I guess. I'll do this in green. The slope, this number, is going to tell us basically how steep the line is. This is a shallow line. This is a super steep line that goes up. Here's a super steep line that goes down, and there's like shallow lines that go down, whatever. The bigger the number, the steeper the line. The like fraction, if it's like a fraction number, like this is like 1/10, that's like a super shallow line. If it's a positive number, then that shit goes up. If it's a negative number, then that shit goes down. That's all you need to know. So here, for 3, we want the line to go up 3 units for every 1 unit it goes over. So we can just basically take any 2 points and see if that's true. So for A, we can start here, and we want it to go up 3, 1, 2, 3, and then over 1. This should be where the next point is. So that's actually bad from this perspective too. A is doubly wrong. How about C? Well, C, I bet C is going to be right. No, it's not. It's not even freaking right. Jesus. All right, so C is wrong also, because let's just start here. Here, this is just like, I'm using this point because it's an easy point. It's like an actual point that we know, as opposed to like this, you know what I mean? It's like where we'd have to estimate. This is like a point we actually know. From here, because the slope is 3, +3, we want it to go up 3, 1, 2, 3, and then we want it to go over 1. We want the point to be here, but it's not. It's like a little too far over. Another way you can think about it, let's just use these 2 points. This line goes up 2 over 1. That's like what the line does. It goes up 2 over 1. That's got a slope of 2, not 3, so this is wrong from that perspective too. And D is wrong because the slope, this has got to be -3, right? Okay, yeah. Because they usually don't make these answer choices like wrong in that many ways. So this is going to go down 3, and it is going to go over 1. That's super hype. The slope is like kind of right, but the line is going down instead of up. Our slope up here, our slope is not -3. That's not the slope. Our slope is +3. We want the line to be going up, not down. So D is wrong from the slope perspective too. If you got this question wrong for non-careless reasons, like not reasons other than like, oh, I was going too fast and I made some foolish mistake, just do graphing linear equations questions in the con SAT practice. you really should be able to get this question, and you should be able to get this question quickly. It's super easy to learn how to use this y-intercept slope stuff to look at graphs. Yeah. All right, cool. Question 3. Which of the following expressions is equivalent to this one? And then there's these 4. This is interesting because it's a little more complicated than just like foiling. You know, like if you had like x squared plus 5x plus 6, like instead of this would be an easier problem to solve because it would just be like, hey, like, foil this. What is this? It's 2 and 3. Oh my God. Yes, it's 2 and 3. And then so we would like foil and then like look for the answer and the answer choices and like be done. This is like a little bit harder because these answers aren't clean foils. They're like clean foils plus this like leftover random bullshit. So, I guess I'll say that like this question has the somewhat common feature of like, this is question 3. It's supposed to be easy. It is in fact an easy question, but it like looks a little harder. You're like, oh my God, there's like something in there to like throw you off and freak you out. Let's see, how would I do this? My first approach probably is to like see what these answer choices tell us about what our job is, because our job really is not to just work from here and then try to foil it. That doesn't make sense because we're not going to end up with 2 things. We're going to end up with some other random thing. So it really feels like we want to be working backward from the answer choices up here. So let's just like check answer choice 1 or answer choice A and see like what it does. And I guess really what we should just do is expand these and see if it fits, Maybe we could be a little smarter. So let's just expand this one. We're going to look at A. Here's A. X plus 1, x plus 9, plus 12. Here, when I am expanding, I never use shortcuts even in these super easy questions because it's like the main place where I mess things up. So I go first, outside, inside, last. And I like really don't skip. I never skip this step of the like combining these and getting to 10x immediately. Most of the time I'm capable of doing it, but sometimes I fuck it up and it's super hard to notice when you fuck it up because you fucked it up in your head. There's no like going back. Right, okay, so what? This is x, oh boy, is this the right answer? X squared plus 10x plus, what's 9 plus 12? It's 21, plus 21. Oh my God, it's right. Great. We can do a little bit of like critical thinking here if we want. It's pretty convenient that answer choice A is the right answer. Feels pretty clear that like this is the kind of question the SAT people like expect us to be doing with guess and check in the answer choices. And so like if this was question 13 and I tried that and answer choice A was right, I'd immediately be like super suspicious about that because like 13 is supposed to be this really hard question. I just had this experience of like seeming to solve it really easily. Like that's super sus. But this is not our situation. It's question 3. It's supposed to be easy. We had an unsurprisingly easy time doing it. Don't question it. It's fine. You're probably fine. That said, we could think a little bit more about the other answers. Would it make sense that this 12x is the wrong thing to put instead of 12? I mean, I think, yeah. We can just stay with this. This is x squared plus 10x, what is it, plus 9? Like the way to compare that, the thing that's different, it's not the x part. Here's the 10x, here's the 10x. It's not the x squared part. It's the 21 part. So adding any x's is bad. My guess, actually, is, I'll make this a little, all right. My guess is that these other ones, this 3 and the 7, are going to be off by like an x. That's not even true though. So we're going to expand C just for funsies. Here, on the real test, I have long since moved on, but we're just doing this for fun. X, we're going to expand this, x plus 3, x plus 7. And we're not going to include this. We're just going to think about what's missing. So let's expand it. Again, I'm not going to do the shortcut. First, outside, inside. And even right now, it's like 7x plus 3. Oh, this is going to be 10x. This is also the same as this 10x. So we're not going to be adding 5x to it. We're not. This is wrong. Right? All right, but then the question is, well, okay, so it's 3 plus 3 times 7. This is 21. Oh, well, that is 21 already. So we don't need to add shit to it. So adding a 5, that's no good. We want 21. We have 21. This is great. All right, so screw that. Oh, I'm just realizing right now that like maybe the way that you mess this up by doing C or D is like just straight foiling it from here, you know? You start from this. You're like, oh boy, this factors into this. And then you're like, it can't be A or B because that's the wrong thing. And then you're like, oh man, I gotta choose between C and D. And like, I don't get what the hell's going on with this added random shit, but I'm just gonna choose one because I'm in a hurry and I'm freaking out. Yeah, I could see getting C or D wrong for that reason, and I could see I see why they put these answers here. You know, um, I guess the moral, if you missed it for that reason, is just like slow the goddamn hell down. This is question 3. If you are like guessing confusedly on question 3, take a step back, give yourself a little bit more time. You'll probably be able to get it right if you come back to it. This actually is a good candidate if you ended up in that situation to put a star on it, forget about it for a while, come back to it when you have more time at the end of the section, and then like relax and do it right. Very likely that you'll come back and actually like change your answer from C or D to the right one. Is A the right answer? Yes. Hey, good. All right, cool. Oh, we'll go to question 4 now. In the XY plane, point A, ugh, gross. We have these two lines. Y is greater than both of these things. I think here, greater than or equal to and greater than, this is an easy thing to fuck up, you know? I bet some of these answer choices are going to be wrong because like, oh, you thought that it was less than that, you know? It's just like low-hanging fruit for people to mess up on, and that's where they put traps. All right, so y is greater than or equal to negative 2x plus 11. This is just a line. All right, fine. Here's another line. Y is greater than 3x minus 9. All right, so these are these two equations. In the xy plane, point A is contained in the graph of the solution set of the system of inequalities above. That's confusing. I'll explain what that wording means. Which of the following could be the coordinates of point A? So it's like, okay, so we're just going to be like, well, basically what we need to do is draw the graph, look at the solution set, which I'll describe, and then pick which of these points actually falls in there. So maybe you know this, maybe you don't, but when you have like a normal system of equations, you know, let's say like the line y equals 2x and the line y equals negative, oh God, let's be nice, negative x plus 2. Here, y equals 2x, let's just call it this line, right? Kind of steep, crosses the y-axis is 0. Here's this line, it's plus 2, so it's going to come here. And then it's like a little less steep, but it goes down. All right, so hopefully all of this is familiar, but if this is like a normal ass system of equations, the solution, what they're talking about, the solution is just the point, the one point where they cross. That's like the thing about lines is they only cross at one place. That's why you can find a solution to a normal system of equations. So here we're talking about solution. This is the same word solution as appears here. The reason why we have to talk about solution sets, though, or we talk about A being contained in the graph of the solution set of this system of inequalities is because of the inequalities part. And here I'll just actually graph the thing. Inequalities are different than lines. Whereas lines are like all the places where one specific thing is true, you know, where like y is 2x. Well, if x is 1, the only thing that is 2 times 1 is 2. You know, there are no other numbers that are 2 times 1 that aren't 2. It's just there's 1.12. But that's not true for inequalities. You know, if we change this to, you know, y is greater than 2x, there all of a sudden are a ton of numbers that work. You know, if x is 1, then the solution set for y, if x is 1, then the solution set for y, like 2 works. Actually, it doesn't work. Right? Greater than or equal to. 2 works because 2 times x is 2, so that's fine. 2 is greater than or equal to 2 times 1. But 3 works too, you know, for y, because 3 is greater than 2 times 1, and 4 is greater than 2 times 1, and 5 is greater, and 6 is greater, blah, blah, blah. So all of a sudden for these inequalities, like there's literally infinite solutions. So what you get is a line and then this whole big area of crap that also works. And so when you have two inequalities and you graph them, they end up with like overlapping areas of crap that work for them. And like in the Venn diagram where they both work, that's the solution set. Okay, that's kind of a long thing, but hopefully this will just be, I mean, in fact, it's a lot simpler. We're going to use blue and green. So we're just going to graph this to start. You could also, it might literally be faster, we'll see, like, stay tuned. It might literally be faster just to plug and chug and see which of these work for both of them, like where it's true. But I think graphing is probably also pretty fast. I'm gonna graph this one first. This one, I always start with the y-intercept. This is gonna start at positive 11. It's gonna start at positive 11 way up here. Because this is the y-intercept. And then it's gonna go down, minus 2x. It's gonna go down sort of like this way. Like, yeah, like that steep, I guess, ish. Okay. Sure. All right. Then we use green. Oh, right. So this graph is all the points that are greater than or equal to this line. So it's actually really all of these areas too. This whole area above the line is the area where y is greater than or equal to this little borderline. All right. And then for green, I'm going to go y is greater than 3x minus 9. So again, I'm going to start with this y-intercept. Minus 9 is way down here. And this is going to go up steeper, 3x, like that, sure. Oftentimes graphs like this, especially for like a question like question 4, again, this is easy question. A graph like this should be enough. I guess technically speaking, if we're doing it right, because this is greater than, not greater than, or equal to, points on this line don't work because they aren't actually greater than. Y isn't greater than 3x minus 9. It's actually like the same thing as 3x minus 9. So if we're being like, good Boy Scouts and Girl Scouts, we're drawing a little dotted line here. Fine. But the thing to point out is like, all right, it's cross-hatched in this direction. And the area that we're thinking about, I'm going to like clear this out, but it's this area. We don't care about this. This is stuff that works for the second equation, but not the first one. And this is stuff that works for the first equation, but not the second one. We care about this area right here. Oh God, we probably are going to have to plug some of these in too, huh? Well, all right. Loki probably would have been faster in hindsight, just to start by doing this. This didn't take that long, but did take a little bit. It is anyway going to help us like zoom in on some of the ones that we think are maybe more likely. Like I don't think that the 0.21 is terribly likely to actually fall in. I mean, this is a shitty graph, so I'm a shitty drawer. It might be that this one works, but I actually don't think it's super likely. This feels like too low. Same thing with 4, 1. This feels, so 4 over, right, and 1 up. This feels like it's probably too low. We're looking for like a higher one. I'm like, well, we're going to double check this, but I'm betting it's C. But my guess is that D is going to be like too far to the right, like that 6 and 6 is going to end up be like here. And that 4 and 5 is going to like work. It's like a little bit over to the right and then pretty far up. And that's kind of what we want, is things that are far up. So we're going to use this graph to intelligently check answer choice C first. And what checking it looks like is just plugging it in to both, right? So I'll just do this up here, I guess. So the 5 is the y, 4 is the x. We're going to ask, is 5 greater than or equal to negative 2 times 4 plus 11? Right, so 5 is greater than or equal to negative 2 times 4, this is negative 8, plus 11, so that's just 11 minus 8. 5 is greater than or equal to, what is this, 3? 3. Well, hey, that's true. Hooray! All right, cool. So that's good so far. And then I'll do this one on the other side. We're going to ask, is 5 greater than, we're going to do this with this one, 3 times 4 minus 9. Just asking, is this true? Well, is 3 times 4 is 12. 12 minus 9 is 3, right? So it's 5 greater than or equal to, or sorry, greater than 3. That's true too. This works. Cool. I would say, like, probably because I'm biased toward drawing graphs, I would have done this. Like, my guess is that the whole graph thing that I did, plus using it to check C, still slower than just checking each of these. But I don't know. Depends how fast you are at, like, doing this plugging in. I mean, doing this 3 times, checking A, B, C, probably could maybe slower than drawing the graph and checking first try. But anyway, this is how we're going to get to C. I'll actually maybe just show like what's wrong with D, or like what a wrong plugin looks like, just for education's sake. I'm going to move this down here. I'll just rewrite both of these equations first. We got y is greater than or equal to negative 2x plus 11. And then over here, we'll do y is greater than 3x minus 9. We're just going to check D. So we're going to check this down here. So we're just plugging in 6 and 6, right? So we're asking, is 6 greater than or equal to negative 2 times 6 plus 11? Is this a true thing? Well, 6 greater than or equal to, this is negative 12 plus 11. Well, this is going to work. 6 is greater than or equal to negative 1. That's fine. Well, shit, I sure hope this doesn't work. All right, so y, this is going to be 6. We want 3 times 6. Oh, this doesn't work. Minus 9. We just plugged in 6 for x and y. Well, is 6 greater than 18 minus 9? Fucking no, because 6 is not greater than 9. Let's get the red out. Fucking no, bro. No. Okay, so this is wrong. Great. On the real test, don't waste your time checking this. If you get the right answer, and it's question 4, you don't need to be meta worried about them playing crazy mind games on you. You probably just did it right and got the right answer. All right, cool. Here comes question 5. Let's see. Let's move this over a little bit. In the xy plane, line L passes through these 2 points, 0, 1, and 1, 4. Which of the following is an equation of line L? Cool. So we're sort of working backward from 2 coordinates. Well, jeez. I mean, these early questions, these are easy. As I was saying, it's like, okay, what are the 2 things we care about for line equations? Well, the 2 things we care about are the y-intercept. These are 4 line equations that are all in y-intercept form. Or what is it called? Slope-intercept form. So the things we care about are the y-intercepts and the slopes. And so these questions, or these answer choices, are either going to be wrong because they have the wrong y-intercept, or wrong because they have the wrong slope. And the thing is, and then this is question 5, so it's easy. They just gave us the y-intercept. The y-intercept is 1. Here's x is 0, y is 1. So we need the y-intercept to be this. This is wrong because it's negative 1 and not 1. This is also wrong because it's negative 1 and not 1. This makes our job considerably easier because instead of asking what's the slope, we instead get to ask, is the slope this or this? I want to pause. Think about that. We've eliminated B and D. One of A or C is right. The only difference between A and C is that A has the slope of this, 1/3. C has a slope 3. So our question isn't, let's try to figure out what the slope is. Our question is it 1/3 or is it 3? It's one of these 2. Well, slope is rise over run. That's upness versus overness. Upness over overness. How far does it go up for every one thing it moves over, for how many things it goes over? So we can just think about the point 0, 1. How much is it going to go up? Maybe I'll do it like this. We're going to start from 0, 1, and we're going to end up at 1, 4. I'll use little commas here. Well, what happens between these 2 points? I'll label this. This is x, this is y. Why is this? This is the x coordinate here. This is the x coordinate. These are 0 and 1. And then the y coordinates are 1 and 4. So we're asking, how far is it going to go over? Well, it's going to go over 1. How much is it going to go up? It's going to go up by 3. Why? Because it's going from 1 up 3 to 4. There's 1, 2, 3, 4. Right? So it's going to go up 3 over 4. Up 3 over 4. Or sorry, oh my god, I'm so dumb. Up 3 over 1. Up 3 over 1. The slope is frickin' 3. C is right. All right. Hopefully that's right. Is that right? Oh my god, I looked at the wrong question. I thought I was wrong. All right. C is right. Cool. All right. Question 6. Well, should I think about other ways of doing this question? Maybe you could graph it, you know? Actually, yeah. Let's try this. Let's see how slow this is. My guess is it's slow. I mean, this whole getting rid of B and D because of the y-intercept thing, this is so goddamn fast. You know, you definitely want to do this. This, boom, boom. This is amazing. This is what you want to do. But yeah, okay. Alternatively, though, you know, we use purple. This is the other way of doing it. We're going to draw a graph. Actually, dude, this is probably pretty good too. Because you're looking at the graph, and if you force yourself to draw the graph, this is probably how you recognize that, like, oh, they did give us the y-intercept. Because we have the point 0, 1. That's this point, 0, 1. And then we want the point 1, comma 4. We're going to go over, and we're going to go, like, up 1, 2, 3, 4. Man, this is another, this is pretty solid. Because now we're drawing this graph, right? And then like we're like, which of these is the equation? First off, A, we're like, we get to the same place. Oh, well, the y-intercept needs to be +1, so screw B and D. And then we ask ourselves the same question: is the slope, is it like a steep line or is it a shallow line? And we can just see that it's a really steep line, so the slope's got to be 3. It's not going to be 1/3. A slope with 1/3 would look like that. It'd be super shallow, super shallow. So actually, graphing is a pretty solid way to go. All right, cool. Question 6. Here, as we move from question 5 to question 6, internally I'm thinking to myself, like, these questions are going to start to get a little more difficult. We shouldn't just like breeze through these now. Oh boy. Oh god, this, I hate this. What value of x? We're just solving for x. What value of x satisfies the equation above? So here's one thing not to do. You can't split these square roots up. We're gonna move all this shit over to the other side. That's what we'll start by doing. We're gonna go square root x plus 28. We're gonna square both sides probably. Equals, and then we're gonna go +2 because we are adding this whole big ass block to both sides. So we're gonna end up with +2 square root x plus 1. Ugh, this is the worst. So we're gonna square both sides. So let's see, I'll put this in this. Square both sides. Now the thing to remember that's probably like the way to mess this up is, so squaring this is easy. This just turns out to be x plus 28. Is it plus or minus x plus 28? No, it's not. This is, yeah, so the thing to mix this up is this isn't, you can't only square this. You can't go 2x plus 1. That would be only squaring this. You also like can't, well, yeah, it's like this squared, you have to like think about this. You have to square both. You have to square this and you have to square this. That's the thing you need to think about. So it ends up being 4. This is 2 squared. 2 squared is 4, and then multiplied by x plus 1. This clearly is the hard step. Maybe I should show it a little bit more explicitly then. We got x plus 28. We're going to square this whole ass thing. Squared, that's what we're doing. We're also going to square this whole ass thing. Squared, this is the situation. And when you're taking x plus 28 squared, or the square root of this whole thing squared, that's just like root of anything. I don't even care what it is. Times the square root of the same thing. That's just the thing, you know? So like the square root of 2 times the square root of 2, that's 2. because the square root, that's what that is. The square root of 2 is whatever thing you can square to get 2. All right, so this is our like clever way of getting rid of this annoying radical sign, is we need to square both sides to get rid of it. And when we do, we just end up with x plus 28 on this side. I guess there's not much to show there. But with this one, the thing about, I guess the rule that I should write is, here, we'll write it like this. This is a rule. A times b squared is not, it's not a squared plus b squared. It's not a squared b. It's not ab squared. It's none of those things. That's not what it is. Instead, it works kind of like distribution. I mean, this is literally, we call it as distribution, but it works kind of like this, where if we have two things that are added to each other in parentheses, you have to do it to both of them. It works that same way, except with multiplication and exponents here. You have to do it to both of them. So this equals a squared b squared. That's the rule. All right, fine. So just to be a little bit more explicit about this, this is 2 squared times x plus 1. Oh, well, square, well, yeah, I'll write it out. I'll write it like this. Squared. 2 squared plus square root of x plus 1 squared. And then the same thing's up here. The square root of x plus 1, this is x plus 1. Or sorry, the square root of x plus 1 squared, that's x plus 1. That times 4. All right, that's how we get here. All right, I'll move this back up. And from here, this is an algebra problem. You're just going to do algebra shit, right? So, oh God, what are we going to do first? Let's distribute this, and so we can get all the x's in the same place. So we got 4x plus 4. All right, that's x plus 28. Now I'm going to take this x and move it over here. The reason why I'm going to take this x and move it over here instead of the other way around is that it's going to end up being positive. If we took this x and moved it over here, we would end up with negative 3x, and that's gross to me. Like, negative numbers are annoying, so fuck that. I'm going to take this, move it over here. So that part is going to be 3x. Why? We're subtracting x from both sides. Let's take the 4 and move it over here. We're going to subtract 4 from both sides. I'm going to do that. So this is 28 minus 4. This is 24. This is how we know we're on the right track. 24 and 3, these are fantastic numbers. 24 divided by 3. I'm going to, well, yeah, 24 divided by 3, this is 8x. All right, cool. So 6 is A. And A is the right answer. Great. We'll move on. Boop boo. Question 7. Oh boy, geometry. Fine. In this triangle, side AC, this side, here's a note. As I'm reading, whenever there's a freaking diagram or an equation or whatever, and they're describing it, I always make sure that I'm constantly double checking to like follow along with what the fuck they're saying. In triangle ABC above, that's this one. Triangle ABC. This is a triangle. Triangle ABC. ABC, triangle. Cool. Right? Side AC. What side? AC. This side. AC. In the triangle. It's part of the triangle. All right, cool. Side AC is extended to point D. Oh, look, it goes over here. All right, fine. What is the value of y minus x? Oh, interesting. Well, I'll tell you what. Y plus x is 180. I'll tell you that much. This is a rule that you just need to know. I'll probably write this down because I bet we use it. The rule is that when you have two angles, or when you have an angle that like splits a straight ass line into two, call this A, call this B. A plus B, that's going to be 180. These two angles are going to add to 180 degrees because a straight line is 180 degrees. That's just a fact. If you didn't know that, don't question it. It's facts. Deal. Okay, fine. We'll put degrees here. All right, we're probably going to use this rule, is my guess. We aren't caring about that quite yet, though, because we need to know what y minus x is. We probably are just going to need to know what x is. I guess we need to know what both of them are. So we need to figure out what x is. In order to figure out what y minus x is, we need to find some way of figuring out what y is, or we need to find some way of figuring out what x is. And x is going to be easier to find because, oh, here's another rule. And if you don't know these rules, you want to look at, I think, circle theorems questions in Khan Academy, or in Khan Academy you can look at, let me just see, congruence and similarity. Congruence and similarity, I'll write this down. Congruence and similarity questions. That's the kind of question that tests these rules. Again, in Khan Academy, that's like the category where they teach it / give you a bunch of practice problems. Anyway, here's another rule. Here's rule number 1. That's this one. Rule number 2 is that if you have any triangle, I don't care what it looks like, any triangle, the angles inside the triangle, those are also 180. That's just another fact. So this plus this plus this, that's 180. Because these, hey, remember, yeah, they're in a triangle. They're in a triangle ABC. So the thing is that 105 degrees plus 35 degrees plus x, that's 180 degrees. I just so sense that there's some shortcut from here to y minus x, but okay. The shortcut is that because x and y add to 180, and because x and the other shit add to 180, that y has to be this other shit. You know, I'm like not smart enough to like turn that into a big old shortcut, but I am smart enough to do well on the SAT even without it. So we're just going to keep doing this. We're just going to go solve for x. It's going to be what? We just need to subtract both of these from 180. So let's see, 180 minus, let's do 35 first. Oh God, my life, please. Oh Jesus. Oh God. Oh God. Oh, is this a 5? It's a 5. This is a 5. Okay. Whew. All right, here we go. 145. Does that seem right? Yes, it does. All right, 145 minus 105. Oh, this is so much easier. Thank God. Okay, so this is 40. X is 40. X is 40. How do we get there? Again, we did minus 35 minus 105. All right, so x is 40. Well, what's y? Well, x plus y is 180. So y is going to be 140. Because, 40 here, x is 40, here's 40, plus y is 180. So y is 140. These are more facts. Right, okay, cool. So now we're wondering what y minus x is. Well, 140 minus 40, that's 100. All right, was I really being super dumb? Trying to think, like, I feel like there's some smart kid way of skipping right to that 100 or something. It's like being like, this, all of this is 140. Oh yeah, that's the smart kid way of doing it. Is you're like, this is y, and it's 140. And so you just subtract 140 from 180 and then you get x. That's the smart kid way of doing it. But, well, yeah, if you're a smart kid and you did it that way, that's dope. I think there's some potential reason, as you saw me thinking through there, to like try to keep in mind smart kid, fancy ways of doing stuff. But on the other hand, I mean, you genuinely saw me fail to see this at the outset. And the resulting way I did it was a little bit slower, but I still got the right answer. I did get the right answer, right? I sure hope so. Is it 100? Yes, it is. All right, cool. We're going to go to, I'll change the color to the appropriate color. We're going to go to question 8. All right, here we go. In the XY plane, almost all of these questions that start with this in the XY plane, I like this. This shit in the XY plane. This almost always means graph it. Because what they're doing is like, they could have literally just shown you a graph of an XY plane, which looks like a graph. They're like, hey, look at this XY plane. But instead, they've decided to like tell you the story like once upon a time there was a graph in an XY plane that you have to use your imagination in order to interact with. And usually they're just doing that to make it harder for no reason. So oftentimes when they say this, the first thing to do is like, all right, fine, I'll just draw the graph and use that graph. That's actually, yeah, that's what you saw me doing up here. Where was it? Up here in question frickin' this one. Oh yeah, yeah. In this one, here's in the XY plane. Also in this one, in the XY plane. That's why I drew this graph here. Is this all of these have in common in the XY plane. Usually graphing it is a solid way of approaching it. All right, fine. In the XY plane, the point 2 comma 6 lies on the graph of y equals k over x, where k is a constant. Oh god, that's terrible. Which of the following point must also lie on the graph? So here's the equation. Y equals k over x. That's terrible. I hate that. I hate that. But okay, which of the following points must also lie on the graph? Here, two come. Oh, this is so easy though. So they're giving us a point. Actually, yeah, maybe I'll back up. This is question 8. Question 8 here. These are medium difficulty questions. A lot of them intentionally designed to like look scary, and this one is scary for sure. Partially because I was like, oh, you should graph it, but this is not a fucking line, man. This is y equals, what is it, like 1 over x? This is not a line. It's not going to look like a line. Try it in your graphing calculator. It does not look like a line. So it's like annoying and terrible, and I hate it. And you saw me panicking, you know. But then again, this is not the hardest question on the test. And the test really doesn't test our understanding. The SAT, this test, does not test our understanding of like weirdly structured equations like this. And so because it's question 8, it's like understandable that they throw this like weird shit our way, but we should also kind of suspect that there's a normal person way of doing this question. And it comes down to this. They've given us this information. We want to use all the information we can, and this information is really important. They've given us a coordinate, the point 2 comma 6. Well, and this is an xy coordinate, and what we can do is use this to solve for k. K is a constant. What constant means, k is just a number. If we figure out what number that is, it'll just stay that number. It doesn't change depending on what you're plugging into it, like x and y do. So we're just going to solve for k. This is the way to solve this question is we're going to plug these points in for x and y. We're going to solve for k, and then we're going to, I don't know what the next steps are. Probably either plug these in or, my guess is going to be plugging this in, but let's see. So we're going to plug 2 and 6 in for x and y. So we're going to go 6 is the y, and k over 2. And then we're going to solve for k. We're going to multiply both sides by 2. We're going to get rid of this 2. We're going to put it over here. 12. 6 times 2 is 12. 12 is k. K is 12. All right, well, so the equation is y is 12 over x. And now the question is, we need a situation. Actually, we could even make it easier by, we're going to just change this around a little bit. Let's move x over here. So instead of thinking like, what are x's where when you take 12 divided by that x, you get these y's, we can just move this over here and get x times y equals 12. Here again, we're just multiplying both sides by x. That's what's happening. This x is going to cancel. Or sorry, this x is going to cancel. We're going to add the x over here. And we're doing this for sheer convenience sake, to make this equation easier. Now the right answer is any two numbers that when you multiply them, you get 12, right? So 1 and 3, no. 1 times 4, no. 3 times 3, no. 3 times 4, yes. D is right. Right. Is D right? Yes. Cool. Alternatively, you could do it this way, where you're plugging each of them in. You're thinking, so like, let's try A. I'll skip to the alternative here. Alternative is in purple. We're trying A, y equals 12 over x. And so we're going to, like, y is 3, and it's 12 over 1. Well, 3 does not equal 12 over 1. And you could go through it, etc. So it's not like this way is the only way of doing it. Definitely, though, the important thing is being able to solve for k. And here I would sort of like, again, backing up, the important thing is like, I mean, you even saw me, my first instinct was like, probably we're going to end up graphing this line. I like assumed it was going to be a line, and then I assumed we were also going to be drawing a graph of it. And that's like the kind of misdirection that's pretty common once you get to these like medium difficulty questions. I was going in hoping to graph it. And then we got thrown this weird ass equation. And the real core thing is not to panic, you know, and to be kind of like confident in the boundaries of the kind of shit the test does. You know, the test on question 8 is not going to throw us some crazy ass curveball that is going to take 10 hours to solve. Instead, we asked, what can we do with this other information? You know, they gave us an x, they gave us a y, let's use that. Well, here's x and y, let's use that to solve for k. And then from there, it sort of snowballs. All right, we're going to go to 9 now. Good. So 9. This is what's called an isolating quantities question. I'm going to write this up here. Isolating quantities. Isolating quantities. They're pretty recognizable actually because they start with an equation up here, and then all of the answer choices are different versions of like rearranged versions of this same equation. And actually the other thing to notice too is like here in this equation, Q is alone. It's like Q equals blah. And in all 4 of these answer choices, it's not that, it's H equals blah instead. The reason why I'm teaching you how to recognize this is because the other thing that all these isolating quantities problems have in common is this super big long paragraph that sets it up almost like it's a word problem that you have to understand. You know, the formula above is used to estimate the ideal quantity, Q, remember that, Q is quantity, of items a store manager needs to order, given the demand quantity, D, don't mess up demand quantity from ideal quantity, or I guess it's the ideal stored quantity, the setup cost per order, that's K. So K is the setup cost. Let's keep track of all these meanings, right? So here I'm just going to say, this seems like a word problem. It seems like the kind of thing where we need to care what these things actually stand for. And so we're reading along and we're like, oh God, I have to like keep track of all this shit. And then all of these things, again, all of these isolating quantities questions have this in common. They then ask, which of the following correctly expresses the storage cost per item in terms of, this is the big thing. They ask, which of these answer choices expresses one thing in terms of the other things? So here the thing they're pointing to is H. They're saying, which of the following correctly expresses the storage cost, which is H. Here's storage cost per item is H. And they're asking, which of these equations gives you the storage cost in terms of the other shit? And the reason why I'm spending so much time on this setup stuff is that as a result, it turns out that you don't actually have to give a shit about what any of this stuff stands for. Instead, they're saying, hey, look at this equation. Could you please move shit around so that H is alone on the left side? That's all they want. They're not asking you to do anything to it or figure out how many freaking demands they need to order, how many items they need to order given the demand or any of that shit. You don't have to interact with the meanings of these symbols. You just need to move them around so that H is alone. All right, that is the hardest part of questions like these. It's why they often come up later in the test or like medium difficulty in the test. The pure fact of that having to read all of this and getting scared is part of the hardness of a question like this. Fortunately, once you get past that point and you realize all I have to do is move shit around, it gets a lot easier. So here, I'm just gonna do this. Q equals square root 2dk over h. Generally speaking, you want to deal with the shit that is on the outside first. Here, like we don't want to be dividing both sides by 2 because 2 is kind of on the inside. It's inside this. We want to deal with this radical first. Well, we want to deal with this radical. And basically, what I'm thinking about it is like we're uncovering this H. We're like getting this H like unburdened by all the crap that's like around it. Because again, we want it to be alone. So the first thing I'm going to do is get rid of this radical. And the way we're going to get rid of this radical is to square both sides. That's what we're going to do. Why? Because again, the square root of all this shit times the square root of all this shit is just the same thing. It's just 2dk over h. Square root of 2dk over h squared is just 2dk over h. We just get rid of the radical. So we're squaring both sides. That's what we're doing. And we end up with q squared equals 2dk over h. Why did we do that? Because h is a little bit more accessible now than it was. It used to be hidden under this radical, now it's not. The next thing I'm going to do, this big brain strats, it's kind of annoying that h is on the bottom. I mean, imagine like moving this over and moving this over and moving this over, we'd still be left with 1 over h, which is not the same as just straight up h. Like h is alone, but it's kind of on the wrong side of the fraction. You can just flip things at the end. That's an allowable move. Is you take the whole goddamn equation, you flip it top to bottom. That's an allowable move, which we could do, but fuck that. I am just going to take this h and move it over. I'm going to take the h, multiply both sides by h. That's what's happening here. I'll do this in pink. Times h, times h. The h's cancel over on the right. And again, I really don't want you to think about it too much in terms of like of this. Think about it as moving. You're going to take this h on the bottom, move it up here. It leaves, doesn't exist anymore. Here's 2dk, and it moves over here. And then all we have to do is get rid of this q squared. So we're just going to divide. This on the left side. This is q squared times h. So we're just going to divide both sides by q squared. Again, we're going to take this, move it over to the other side. And we're doing it by dividing. This is q squared times h. We're dividing both sides by q squared. So I'll just write that. Divide by q squared. That's going to give us what? H equals 2dk over q squared. That's the answer. So fuck these radical ones, because we know our answer doesn't have any radicals in it. And then it's this. It's not this, because this is the wrong way around. It's top to bottom flipped. Which actually, this shit right here, I bet you is what happens if you, at this point, I'll write this in red because it's like danger zone. Q squared equals 2dk over h. And then you're like, I'm going to divide by 2. I'm going to divide by d. I'm going to divide by k. And that gives me h, you know? Divided by 2, divided by d, divided by k. It doesn't give you h alone. You haven't gotten rid of 2 and d and k and left nothing. You've left 1 over h. You done goofed. So this is true, that q squared equals 2dk over 1 over h. But you're not done. 1 over h is not the same thing as h. You got to flip. And this is as I said, you're allowed to do this shit. You can just flip. You take a fraction that looks like this. These two fractions, they're equal to each other. You can flip them. Boom, both, top to bottom. That's allowed. And then you get 2dk over q squared equals h over 1. But that's h. And then you can get to the right answer. But I bet you that's how people get d. That's the big way to get d. All right, I'm going to erase this shit because it's scary and misleading. And then I'm going to write a big X right here. No, you fool. All right. What is that? Was that question 9? Yeah, it was. Question 9, I got it right? It's C, Great, cool. Question 10. In the equation above, C is a constant. If the equation has infinitely many solutions, what is the value of C? Good. Okay, so this question is hard. I mean, and again, right, this question 10, we're expecting these to be kind of hard for some reasons. I would say the reason why this is hard is that it is the question, like, what does it mean for something to have infinitely many solutions? What does that mean? This is actually, it's really important. This is a piece of information that we need to use. It's very powerful. We're going to use it in this to give us the sort of answer. Um, a lot of equations only have one solution. So like, 2x equals 6. This is an equation. This is an equation with one solution. We're going to divide both sides by 2 and x is 3. That's the one solution. X is 3. X isn't 4. It's not 5. There are not infinite different solutions that work. There's one. It's 3. But this is not our situation. The situation in this equation is that there are infinitely many solutions. And so like, what does an equation look like that is that way? And the question is, it's things like this. This equation has infinitely many solutions. Because if x is 1, then 1 is 1. Hey, that's great, that works. If x is 2, then 2 equals 2. That also works too. So 1 works, and 2 works, and 3 works. And infinite other numbers work for an equation like this. So what they're telling us by saying this equation up here has infinitely many solutions is that, well, I don't fully know exactly what we're going to use that information. I can't like see forward into the future into the exact step, but I guarantee you that shit's going to come up. So let's just screw around for a little while. 8x minus 2x, Jesus, times c plus 1 equals x. Oh god. Okay, well, I'll think about this in a couple different ways. 8x minus 2x times c plus 1, god, that's horrible, equals x. One way of thinking of it actually is that all of this shit needs to end up reducing down to x so that we get an equation that looks like this, that has infinitely many solutions. So to say that again, because we know that this has infinitely many solutions, c needs to be the kind of number so that this whole big annoying thing whittles down and simplifies to just x. Because if that happens, then x is x, and then we have infinitely many solutions. You probably think it's unlikely that you did, in fact, do it that way. I think it's probably unlikely that I would, in fact, do it that way. I think I would probably first expand this. Actually, let's follow this out and see how easy it is to do from there. Oh yeah, c needs to be the kind of thing so that this turns out to be x. So what? 8x minus 2x c plus 1. All of this is x? All right, well, the way that all of this is going to turn out to just whittle down to x is if this turns out to whittle down to 7x. How do I know that? Because 8x minus 7x is 1x, and that's what we want. So I could put it this way. I could be like, oh, negative 2x, negative 2x c plus 1 equals 7x. That's a true thing. We want this part to be 7x. Am I just being super dumb? I think I'm being super dumb. I get the sense that I'm super dumb and we could just solve for x right here. In fact, I know that that's the case. But this is going to work. And this is the beauty of the SATs. Like, I'm doing some dumb shit right now, but it's going to end up working because the principles are sound. And just because it's not the fastest or smartest way of doing it doesn't make it wrong. I'm going to keep going here. So minus 2, this is minus 2x times c minus 2x equals 7x. This is just me just distributing. Oh my god, this is terrible. Negative 2x times c equals, I'm going to move this to the other side. I'm going to add 2x to both sides. This is 9x. Then we're going to divide x by both. This is negative 2xc. So this is negative 2 times x times c. We're just going to divide x by both sides. X is going to cancel out. And that's negative 2c equals 9. And then we're going to divide both sides by negative 2. C is going to equal 9 over 2. And that's the answer, so it's D. But this is fucking dumb and bad and stupid. And don't do this way. In fact, actually, that is the straight up wrong answer. I have done many things wrong here. So I'm gonna okay, hold on. Let's see actually. What did I do wrong? maybe first I will simulate what to actually do when you have made a mistake like I have. Man, this was a big mistake somewhere. I'll move this down here for now. Oh God. Yeah, I'm gonna move this. I'm gonna take this. I'm gonna move this down here. Oh my God. Oh, I'm having so much trouble. Yeah, this is just gonna live down here for a second. Instead, what we're gonna do is we're just gonna expand this out. This is what I was saying is gonna be the slightly more realistic version anyway, before I tried to big brain it too much. So we're just gonna expand this. This is minus 2xc plus, oh, this is minus 2x, oh, that's what I did wrong. Minus 2x plus 1. Minus 2x times 1 is negative 2x. I bet that's what I fucked up. I didn't fuck that up. Oh boy, I made some kind of big mistake. And this is going to equal x. And then we're just going to simplify all of this stuff and try and solve for c. Getting this right? Negative 2xc minus 2x equals x. So we're going to combine like terms. 8x minus 2x, this is 6x minus 2xc equals x. Oh, yeah, okay. Now we're going to take this and move it over to the other side. Maybe like swap these two. Let's take the 6x and move it over to the other side. So we've got minus 2xc equals x minus 6x. Taking the 6x, subtracting both sides by 6x. This x minus 6x, that's negative 5x. Well, this is going to be the right answer. Again, we're still just trying to solve for c. Here we can take the x's out. We're going to divide by x. So I'll do this in pink. I bet it was just some dumb little arithmetic error that I made it the other way. Because I don't think the way I was thinking about it was wrong. I just think that I'm bad at like moving shit around. And if I look a little bit more for if I look a little bit more for the specific place where I made an error, I'd be able to find it. Which is something I'm going to demonstrate for you because it's something you should do. So we're going to take these x's out. This is negative 2, c equals negative 5. And then c equals negative 5 over negative 2. That's just c equals 5 over 2. So this is an appropriate answer. And where did we use these infinitely many solutions thing? Yeah, the infinitely many solutions thing is it comes when we canceled this x. Because now we're making it so that no matter what you put in, or sorry, yeah, no matter what you put in for x, this is going to be true. So that's B. All right, let's see where I fucked this up. I'm gonna bring out the top. I'm gonna copy out the top one too. And here, you know, if you understand the question and you don't care how I screwed up, then just skip to the next question. That's fine. What I'm going to model right now is the process of like, first off, like during the test itself, if you find yourself in the situation that I was in, where like you were just like off on some limb, pretty suspicious of like the thing that you were doing, you come up with an answer that like feels sus, like what you should do, mark that shit, come back to it, and then bug check. And so I'm gonna like model bug checking. I'm also gonna be modeling like the kind of like, you know, I think this is kind of likely actually that I just like, you heard me throughout thinking that the way I was doing it was pretty stupid. So I think it's unlikely that I actually would have missed it on the real SAT because I would have marked this question and that way as being stupid and then gone back and checked this, doing the thing that I was describing for you. But I actually also think it's possible that I totally could have missed this question on the SAT. Maybe I didn't have time to go back, for example. And in that case, what I should do is after I get my scores, I should come back and do what I'm about to show you. Now that I have infinite time, I'm going to look back at my work and be like, what did I do? 8x minus 2x times c plus 1 equals x. 8x minus 2x times c plus 1 equals x. And what was my logic? So my logic was that this 2x times c plus 1 equals 7x. And my logic was that 8x minus 7x is x. I mean, that sounds right so far. So what did I do wrong? C plus 1, C plus 1, C plus 1. Why is this turned from a 7 into a 9 instead of a 7 into a 5? Ooh, this 6. What is happening? What is happening? 2x. This I think that reasoning seems right. 8x minus 7x is x. Okay. This is just such a stupid way of going about it. Okay, so minus 2x times c plus 1. This is minus 2xc minus 2x equals 7x. We're going to add x to both sides. This is 9x. There's got to be, I guess there's something wrong with what I've done here. All of this needs to equal x. And yet this doesn't equal 7x? Bro, I'm freaking lost. I'm lost. All right, well, I'm going to straight model something else and admit that I'm lost and come back to this shit later because I'm obviously missing something stupid and small. And the annoying thing is that people watching on YouTube and shit, I'm sure will like see it and be annoyed at this. But deal, you make stupid mistakes too. You make more stupid mistakes than I do, you little bastards. So calm down. All right, I'm just gonna take this, make it really small, put it down here. I'm gonna label it Mike's idiot display. This Mike's idiotic ramblings. And maybe at the end, actually at the end, I'll try and come back, review it, see if I can demonstrate what it looks like when Mike catches shit, with the benefit of hindsight. All right, anyway, is B the right answer? B is the right answer. And we use this infinitely many solutions piece. Yeah, again, the infinitely many solutions piece in this particular question made us feel more comfortable dividing both sides by x. Yeah, and in fact, yeah, the reason why it made us feel more comfortable dividing both sides by x here is that there are other ways that it could not have infinitely many solutions. Like if C was, let's say C is 5. Let's just say C is 5. We could just start from right here. Negative 2x times 5 equals negative 5x. If C is 5, this is negative 10x equals negative 5x. And then we can, like x is going to be not, well, it's going to be a specific thing, which is to say, we'll do, let's just add 5x to both sides. So we'll have negative 5x equals 0. X equals 0. X can't equal 0. In this equation, with C being 5, X turns out to equal one thing, which is one solution, not infinitely many. So the only actual one that works for C is the one that makes it so that these X's cancel out. And like, yeah, so I guess like the roundabout way of doing it is like we divided both sides by X. We did that because we felt comfortable doing it because we are going to end up in a situation where it doesn't matter where you put what you plug in for X. C is going to be the same thing no matter what. All right, that was a little roundabout and shitty, to be honest, but that's what happens when you do chill SATs with Chill Mike. You can maybe ask me a question on that if you're confused in the comments, and I, with the benefit of like actual time to think about it, might generate like a thoughtful, like helpful explanation instead of a Mike's dumb ramblings, all right, question 11. In 1962, the population of a bird species was 2,000. Here I'm reading this paragraph, and there's an equation along with the paragraph, and I'm just like checking, to see. Oh, hey, look, it started at 2,000 in 1962. It started at 2,000. The population, K years after 1962, was 48. Hey, look, here's the number 48 over here too. So this is going to be the stand-in for the population, how many years after 1962. This is 48, and K satisfies the equation above, which is just to say, like, this equation works. This is not a bullshit equation, it actually works. Which of the following is the best interpretation of the number 61 in this context? Oh, cool. All right, so this is an interpreting linear equations question. And what it does is it gives you an equation. It gives you a word explanation, a written English explanation for that question. And then actually, unlike these isolating quantities questions, unlike this one, which looks really similar, right? Like we have an equation and like a written explanation. And this was what's happening down here. We have an equation, then we have a written explanation. The way you can tell these questions apart is by what the answer choices look like. Here, the question is, how can we interpret in English what this number 61 means? And then all of the answer choices are in English. They're like English concepts, the population K, the value of K when the population was this, the difference between this and that. These are English language concepts. Whereas in our isolating quantities question, this is question 9, we had the equation, we had this like English language description of what the equation means, but the answer choices never interacted with the English language descriptions, right? The answer choice, if you remember, it's just all just about moving shit around in the right way. Well, here, because all of the answer choices, question 11, because all the answer choices are in English, they're about the English language meanings of things, we need to care about the actual English language meanings of what's going on. We want to conceive of the situation in the real world that this equation is meant to model. The cool thing is that these linear equations, this is a linear equation. It's actually even in y equals mx plus b form. This is y equals, here's mx, plus b. This is a linear equation, and linear equations follow these same sort of translation rules in terms of like what the different parts, what the b means, what the m means, what the y means, etc. In terms of like real world concepts. One way of thinking about it is that, well, so y equals mx plus b. My favorite way of thinking about it is that this is the sort of start point. So it's like, in the beginning, there was this many of the thing we care about. Or like when you start a gym membership, you have to open up by paying $50 or whatever. This is like how much money or how much or whatever at the beginning. The M, I'll write it in a different color. This is how much shit changes, or like how fast shit changes. I mean, they could use rate of change, but this is like how much things change, So it's gonna start off. You're gonna start off with $50 in your account, and then you're gonna save $5 per week. That's slower than $10 per week. That's slower than $50 per week. That's faster than $25 per week. Whatever. So this is how fast things change over time, or just like as the equation sort of goes. And then x and y are your two variables. They're the two things you're tracking. It's weeks, it's money, etc. Okay, so in 1962, we're just going to track these meanings through this particular equation. In 1962, the population of a bird species was 2,000. That's this. And here we see 1962 is our start point. Is like population in 1962. This is the beginning. 1962, for our purposes, is basically the beginning of time. Like, as far as this equation is concerned, it's like fucking right here, 2000, 0, 2000 in this year, that is at the 0, is 1962. Yeah, in 1962, the population was 2,000. That's this. The population K years, so K is the number of years that go by. Every year that goes by, the population of birds changes. The population K years after 1962 was 48. So here the end result, after some amount of years, this was the population after a bunch of years. and k satisfies the equation above. This is just like, it's like k, this again, it's like this equation works. K doesn't not satisfy the equation above. This equation is not wrong, it's right. Which of the following is the best interpretation of the number 61? So all of these linear equations, all of these equations have the same sort of structure where they start in a certain place and then something happens over and over and over again, and then you end up in a different place. You end up over here. And so that's the same thing that's happening with these birds. So the population of birds started off at 2000, and this is what's happening here. There's years go by, k is 1 and 1 year has gone by, k is 2 and 2 years have gone by, and k is 3 and 3 years have gone by, etc. And the 61 is the slope. It's how fast things change. And in fact, the slope is negative, it's minus 61. And so what's happening is that every year that goes by, we're subtracting 61 from the population. It was 1962. Then in 1963, there were frickin' whatever, 61 less birds, which this is going to be annoying because it's going to get confusing with the years, but there were 2,000 birds, then there were 61 fewer 1 year later, then there's 61 fewer than that a year after that, etc. 61, and this is going to be in the comments, or sorry, in the answer choices, 61 is the number of birds that the population loses every year, year after year after year, losing 61 birds a year. So it sure as fuck is not the population k years after 1962. It's like the change in the population, but the actual population, that's over here. That's the y. That's 48. So it's not the actual population, it's the change in the population. 61 is not the value of k when the population was 48. 61 is not, it took 61 years. The value of k when the population was 48, here the population is 48, 61 is not equal to k. It did not take 61 years. 61 is the thing that happens every k years. It's not the value of k. The difference between the population in 1962 and the population k years after 1960. This is close. Yeah, this is close. I might loop back to this and explain why this is wrong once I've explained why this is right. So D is going to be the average decrease in the population per year. This per year, decrease in population per year. This is like slope shit. Oh, I shouldn't be highlighting it in red. I should be highlighting in green. This something per year is like how to know that they're talking about slope. This is slope keywords right here. You know, because when you're saving up for something, you start with 50 bucks and then you save 50 or $5 per week. You know, you're driving to the store, you started off at your house, you're going to drive 5 miles per hour. All of these something per something, these are slope words. And so 61 is the average decrease in the population per year from 1962 until k years after 1962. And so this is, right, we're starting in 1962, and then in the 3 years that have gone by, the average amount each year that the population has gotten lower is 61 per year. Going back to, so this is right, D is right, I'm just gonna check, D is right, great. The difference between, going back to the difference between C and D, C is missing this per year component. So C is saying that it's the difference between the population at the beginning and the population now, you know, or like however many years have gone by. And that's not true because that number gets bigger and bigger and bigger and bigger. So like, you know, after the population started at 2000 and the difference after the first year was 61, you know? So here, this is what, this is gonna be like 19, oh my God, freaking life, 1939. So this is 1939 birds after 1 year. And literally only for year one, this is true, that 61 is the difference between what it used to be and what it is now, the population k years after. But after we go another year and another year and another year, this difference, the difference between 2000 and 1939, the difference between the population in 1962, which is this, and the population K years after 1962, which is this, gets bigger and bigger and bigger. It doesn't stay at 61. It changes by 61 every single year. But the actual difference is, well, it starts at 61 and then it gets 61 higher. So it's like 122, and then it gets higher and higher and higher and higher. So that's what's wrong with C. Okay. Again, I will say mostly that for this question, if you're having trouble, if you've had trouble following what I was talking about, if you had trouble following this piece, the Khan Academy Interpreting Linear Functions questions, that's what this is called, Interpreting Linear Functions. These questions are pretty solid to just like do a bunch of and kind of get used to how they feel, you know? Just doing straight up pattern recognitions in terms of like which words correspond to which parts of the equation, really helpful. All right, we're gonna move on to question 12. The graph of this function is shown in the xy plane above where y equals f of x. All right, so this is just a graph of a function, y equals f of x. Which of the following functions could define f? Oh yeah, cool, this is great. This kind of question, basically the big thing we need to know is that each of these little factors is a 0 point. So each of these little places represents a place where the graph is going to hit 0. So that's for starters. So like rule number one, let's say rule number one, I'll say each factor. And by factor, I mean like, x minus 3 is an example, is a 0. The other thing to keep in mind is like, it's counterintuitive. If one of the factors is x minus 3, then the 0 is 3. The 0 is positive 3, not negative 3. It's just a thing you have to keep in mind. Oh, I'm sorry, that's a little cut off. The 0 is positive 3, not negative 3. I'm not going to keep describing this in the abstract because it's a lot more easy to understand if I'm just doing it. But first, I'll say rule number 2. If the factor is at an odd power of 1, 3, 5, 7, it's going to bust through the x-axis. And if it's an even power, it's going to bounce off it. So this is an example of busting through, where it's like the graph is hitting the x-axis and it busts through. And this is an example of it bouncing off. Here it's going to hit 0 and bounce off. That's just another thing to memorize. If the factor is at odd power, it busts through. And here, yeah, I'll write these examples. Yeah, I'm gonna make this a little neater and give explicit examples for each of these rules. Each factor is a 0. That's rule number 1. If factor is at an odd power, it busts through. If even, it bounces. So here, so x minus 3, for example, x minus 3, that means 0 at 0, comma 3. All right, here, x minus 3 to the third, that shit busts through. Whereas x minus 3 squared, that bounces. And then I'll look at this and I'll say this is a bounce. And I'll say this is a bust. Now the thing to do, if you're going to big brain it, is just to look at all of the places where this graph hits the x-axis. Here, here, and here. There's 3 places. And then to think, are they going to bounce or the bust in each of these places, and where does it hit the x-axis? This graph hits the x-axis in 3 places. Here, I'll just write this out. This graph busts through. It busts through here at 0, -3. It bounces at 0, -1 and 0, 2. So we want an equation that says x plus 3. That corresponds to this, 0, -3. And we want this to be, to the odd power of some kind. Could be 1 or 3 or 5 or 7. And then it's going to bounce at 0, and we want zeros at negative, or sorry, we want zeros at -1 and +2, which is to say that we want the factor to be +1 and -2, x minus 2. And again, because it's going to bounce at both of these places, we want both of these powers to be even numbers. This is what we're going to use to solve this question. And then we're just going to go through each of these answer choices and like knock off the ones that don't match this system that we have here. Let me first get this out of the way. Oh God. Ooh, God, that looks terrible. Okay. I will give myself some room up there. Yeah. Let's make this just a little bit smaller. Put this down here. Okay, I'll move this later. We'll do the we'll do this right now. So what we want is, let's just check for the first one, x plus 3. Well, this says x minus 3, so that's wrong. This says x minus 3, so that's wrong. Here, these two say x plus 3. We want an x plus 3 with an odd power. This is x plus 3 to an even power, so that's wrong. So D is wrong, and C is right. Now, before I check my answer, this is question 13, or sorry, yeah, it's question 12. So like, it's hard. The way that I would make sure that I sort of have it right is to check the other ones and make sure the other ones match in my supposed right answer, because, there's a chance I messed it up. You've seen me mess things up. And if I did mess up, hopefully I'll catch myself by one of these being wrong. But that's not true here, right? X plus 1 to an even power. We have that, x plus 1 to the 2. We want x minus 2 to an even power, and that's what we have here. So now I can feel pretty confident about moving forward. Here, question 12, is it C? It's C. Great. All right. Oh, let me try and think a little bit more about how you could mess this up. Yeah, I think ways to mess this up are, yeah, as you can see here, right? Like, the ways to mess this up are thinking that x minus 3 as a factor means that the zero is at -3, but it doesn't. It means that, look, you need to switch the signs. This means a 0 at +3, which is the wrong way, right? That's the way to mess it up if you hit A or B. And it looks like with D, yeah, D is testing whether you understood the odd even bounce rule thing. So actually you could even just cleanly say these ones are rule 1, and this is rule 2. And you need to follow both of these rules in order to get it right. Okay, now I'm gonna, well, let's see if I can dodge this. Question 13, it's getting real. Here I will say that unless you are routinely scoring really high on the test, like, God, I don't know. And actually, yeah, this was true starting at 11, starting here. Unless you're scoring pretty high on the test, you should be thinking to yourself through 11 through 15, these are some of the hardest questions on the test. Maybe I should, like, if it looks like I have no idea how to do this question, I should consider skipping it and spending more time on the other questions that I don't know how to do as well, or that I do know how to do better. All right, so 13. Here's these two equations. This is the equation of a circle, because x is squared and y is squared, so that's something. And this is the equation of a line. Which of the following could be the x-coordinate of a solution to the system of equations above? So this is just a line that is going to pass through a circle. at some point. And oh God, it looks like I'm gonna have to use the quadratic formula. How do I know that I'm gonna have to use the quadratic formula? Because this is just how this goddamn thing works. This just looks like quadratic formula. Quadratic formula has stuff plus or minus the square root of stuff over stuff. That's what I'm thinking. Like I'm looking at these answer choices, I'm thinking, oh boy, this is some quadratic formula type shit. Might be a misdirect, but I'm already prepared to do that. First, though, I bet there's an easier way of doing this question because just recognizing that this is a circle, we can like maybe like map it out a little bit. Oh, I don't know. We might. This is question 13. It's probably hard. We probably are gonna have to like dive into the actual equation. But first, let's just like do like a brief graph. That's not. I'm gonna do a brief graph and just like see what's going on. This is a circle with the center at -2, comma, +3. So the center of our circle is -2, +3, 1, 2, 3. For those of you who aren't aware, you can go to circle equations problems in Khan Academy, but the center of the circle is, you have to do the like switchy signy thing, but the x coordinate is at the opposite of this thing, and the y coordinate is at the opposite of this thing. So our circle's center is at -2, comma, 3. It's at that point. That's where the center of the circle is. And this is a little, you know, we can see it's kind of close to where this line is going to be, so, okay. And then the radius of the circle, this is r squared. So the radius of our circle is √40, which straight up sucks. I mean, I don't know how else to describe that. What is the square root of 40? I think it's like between 6 and 7, because 7 squared is 49, and 6 squared is like 36. So if I'm just like ballparking it, I guess it's actually a pretty wide circle now that I think about it. Like, because this is like a big ass circle. I'm just like making a really crappy drawing, but it is pretty big. I mean, the radius is like 6-ish, you know, like call it 6.5-ish. That's pretty big, you know? And more specifically, it's √40. That's how long the radius is. All right, so this is our drawing of the circle. And the point of this is just like maybe to get our bearings to do some sanity checking on it, but I actually doubt that this exercise, like I probably, if I were time pressured, first, if I were time pressured, I would probably skip this question and do it the end. But I would also probably not go about doing this like once I got to like this place, realizing this √40, I'd be like, oh, fuck the graph. But we can just like keep going here. This will be pretty easy. The y-intercept is going to be +4, so it's just one higher, 1, 2, 3, 4. And then it's a -2x, so this line, I've written these in an annoying spot, but this line goes down, and it goes down like kind of steep, like this-ish, and then it goes up. And this I think turns out not really to help us at all. It's not going to tell the difference between any of these. We're looking for like this point basically, and we're looking for the x coordinate of this point, this x comma y, and this graph isn't going to help us tell the difference between these. And as I was expecting, you know, we're probably going to end up having to use the quadratic formula for this. So I'm actually even just gonna, well, I'll move this down. You know, we'll see if we end up using it, but I doubt we do. I'm gonna move this way down here. And instead, I'm just gonna stare right down the barrel of this question, which, all right, so we are in a system of linear, well, it's not system of linear equations, we're in a system of equations questions where one of them is a line, and one of them is this thing that is like super not at all a line. And we need to solve the system. And the way that we can do it is through substitution. Here we have, like one way of doing it, we saw this on like question 1 or whatever, one of the early ones, is to isolate y on both sides. So we could take this equation and try to get y alone. The other thing we could do, though, is because y is alone here, we could just take this and plug it into y here. Because this y is the same as this y, it's sort of similar to setting them equal to each other. We're just taking this part of the equation and shoving it in here, taking advantage of the fact that these are the same y's. And then we're going to solve for x and see if that, well, yeah, I guess what's going to happen is we're going to solve for x, and that's going to force us to use the quadratic equation at some point, and that's going to be horrible, but we're going to take our time, we're going to do it correctly, and then we're going to get one of these answers. Yeah, I would say from the outset, probably you should be able to call that that's going to happen, again, because of the way these answer choices look. You know, if you're thinking to yourself, man, if I did that and solved for x, that seems like a really thorny, horrible thing. These answer choices are like, yeah, dude, it is going to be thorny and horrible. It's question 13, you know, like, what did you expect? So if you're scoring, you know, this is where in real life, on the real actual test, you only have a limited amount of time. So if you're looking at this, you should, I think, you know, 80% of test takers should conclude at this point, fuck that. Goddamn, no, you know, I'm not going to do that, and just skip it and guess and, you know, hope that you have a 1 in 4 chance of getting it right, and save yourself the, you know, you're going to see me. It's going to take me like 8 minutes or whatever to do this with the explanations. If I were doing it fast, it would probably take me like a minute and a half to do it, and I'm quick. And you just use that time better. Use it elsewhere, you know. But if you're scoring really high, or if you have extra time and you've come back to it, this is how you do it. You're going to take this, you're going to plug it in here. So that's what's going to happen. X plus 2 squared plus. We'll be real careful. This is the whole thing. This is going to be a non-stop thorny algebra mess. So we're not going to take shortcuts here. Y is negative 2x plus 4. So we're going to go parentheses, and then we're going to go negative 2x plus 4. This is y. Then we're going to go minus 3. Then we're going to square it. Then we're going to double check. Negative 2x plus 4 minus 3 squared. This is y minus 3 squared. We've substituted it correctly. All right, and then this is 40. Then we're going to expand the shit out of everything to see what we're looking for, or to like see what we're working with. It's going to be terrible, but we're going to do it. All right, this is going to be easier. X squared plus 2x plus 2x plus 4. This is just x times 2 times x times 2. It's basically foiling, if you look at it this way. X squared, 2x, 2x, blah, blah, blah. So that's this. Then we're going to go plus. And then this squared, actually, maybe I can like tease this out. This squared, we're going to zoom in. Ooh. This is negative 2x minus 4, or plus 4, minus 3. Oh, you know what, though? Yeah, we don't need to be too crazy. In fact, here, I'm just going to notice that negative 2x plus 4 minus 3. I wrote this parentheses out of an abundance of caution, these ones right here, but they actually aren't necessary. What we have here is 2x, negative 2x plus 4 minus 3. That's just negative 2x. Negative 2x is plus 4 minus 3, that's plus 1. So I'm just going to combine this to make this squaring step slightly easier. It's still going to be annoying. So now I'm going to do this squaring step. And first I'm going to do a little bit over here. I'm going to do a little bit of combining like terms, you know, just a touch. And then here we're going to FOIL it big time. So actually, yeah, now I will maybe zoom this out. And this is negative 2x, negative 2x plus 1 times negative 2x plus 1, right? And then we're going to do first, outside, inside, last. So first is negative 2x times negative 2x. That's 4x, because negative, two negatives make a positive, 4x squared, because these two x's. Then we're going to do outside. This is minus 2x. Then we're going to do inside. This is minus 2x. Then we're going to do last. That's plus 1. And then we're going to take that and put it in right here. Yeah, so we'll just like, and this is plus, and then it goes 4x squared minus 4x plus 1 equals 40. Oh boy. Now we're going to combine like terms. X squared plus 4x squared, that's 5x squared. Then we got 4x minus 4x. Ooh, that's nice. 4x minus 4x, that's just nothing. And then we got 4 plus 1, that's 5. Equals 40. Oh my god, are we going to not have to use the quadratic formula? This is so simple. Let's just double check. X squared plus 4x, that's 5x. 4x minus 4x, screw that, that's nothing, right? 4x minus 4x, that's 0. Plus 4 plus 1, that's 5. Oh my god. 5x squared equals 35. This is 40 minus 5. All right, we're taking this 5 and moving it over. So 40 minus 5, 35. We're going to divide the 5 now. X squared equals 35 divided by 5, that's 7. Oh, we don't need to use the quadratic formula. This is amazing. X squared is x squared is 7, so we're going to take the square root of both sides. It was plus or minus square root of 7. So square root of 7, this is our right answer. Whew, thank God. 13. A, it's A. Great. Duh. Oof. Seriously? Quadratic formula would have added like a whole ass minute to that question. Okay, cool. Oh, do I want to think a little bit about how you could have messed this problem up? I honestly think that for the vast majority of test takers, the way to screw this problem up is to spend way too long and end up getting it wrong. You know, this question right here is a freaking hard question. There's a lot of ways to approach it in the wrong way and end up wasting a lot of time, you know? And as you can see, like the stuff that I went through, it's even when you get to the point where you're doing it the right way, it's thorny. You really have to not fuck up any of these small steps. And that's like this long circuitous path to get to the right answer. And I think for the vast majority of test takers, you know, the way you're going to pick up points is by skipping questions like 13 quickly so that you can spend more time being careful about questions like 2, not rushing through questions like 2 and making stupid mistakes where you're like, how did I do that? Because you need to make time to spend 8 minutes on question 13. So that's my big takeaway from question 13 is like, most of y'all should learn to recognize this and not do it. Okay. Think of question 14. Oh, this is terrible. Let's see. The equation above can be used to model the population in thousands of a certain city, T years. Here's T. Oh, here's T. Oh, this is annoying that it's T over 3. But this is T. T is the number of years after 2000. Do I see the number 2000 anywhere? I don't. According to the model, the population is predicted to increase by 0.5% every n months. So n is the number of months. Oh, what is the value of n? Interesting. So we don't see n in this equation at all. We are looking, I'm going to look for this 0.5%. And I'll say actually this one question I have done recently, and the last time I did it, I messed this up because I just like thought this read 5%, just straight up. And it took me forever to debug it and realize that it said 0.5% because I was sitting here being like, you know, we're looking for 5%, the concept of 5% in the equation. And I'm seeing this and I'm like, this is not 5%, man. 5% looks like this. This is some crazy shit, some other kind of thing. And then I was like, oh, it's, you know, it's 0.5%. Anyway, though, we see the concept of 0.5% in here. And just as a brief like model of how percentages work, right? 25%, that's 25 over 100. That's the same as 0.25. And so when you're trying to like increase something by 25%, you know, like 25% more than, oh, I don't know, 70. The way this works out in math is just 70 times 1.25. Because this 1 is the 100% of 70, it's like you're going to get 70, and you're going to get more than 70. How much more? 25% more. So this is what it would look like to get an increase of 25%, an increase of 0.5%, just straight up looks like this. That's what it looks like. Here's the 1, and then here's the, it's not 50%, it's not 5%, it's 0.5%. Okay. So we're following the truth, or we're following the sort of story of this question. And we just want to track and see what's going on. The equation can be used to model the population. Here's the population in thousands of a city. Here's T years after 2000. And it's increasing over time. And this is this sort of base value that it's increasing by. And it's increasing 0.5% every so often. They're saying every n months. And then their question, all of these answer choices are values of n. The units that these are in, these are like how many months? That's in the end what this question is asking about, is the number of months that it takes to do something. And the thing that we're being asked about is, according to the model, the population is predicted to increase by 5%. That's this, every n months. This is how many months does it take to increase the population by 0.5%. Well, we can just back up a tiny bit and think about how exponential equations work, like what they do, sort of similar to what we were talking about with linear equations. Well, linear equations, they start off in a certain point, and then something gets added to that value over time. You're going to start off with 50 bucks in your bank account, and then every week you're adding the same amount. You're saving 5 bucks per week, so it's plus 5, plus 5, plus 5. Exponential equations work the same way, except the thing that you're doing isn't adding, it's multiplying. So you can think of this basically as the same thing as the b from the y equals mx plus b. It's the starting point. Here there's 215. And the thing that's going to happen to that 215, I'm going to write this in a different color. The thing that's happening to that 215 is it's getting multiplied by 1.005 a bunch of times. And the number of times it's getting multiplied is like the sort of number of cycles that this equation is going through. This equation describes a starting point where you start with the number 215, and then you multiply it by 1.005, and that's a 5% increase. That's what a 5% increase looks like, is you take 215 and then you multiply by 0.005. I'm sorry, I said 5%. God, I've made this mistake so many times. 0.5%, 0.005. And so this exponential equation, basically every time like we do a multiplication, that represents a 5% increase. So you can imagine at a certain point, we're going to do another 0.5% increase. So it's going to be like 0.5% up, 0.5% up, 0.5% up. And the number, like the part of this equation that represents how many times we're multiplying the number by 1.005, how many times we're doing this 5% increase, that's the exponent. That's this right here. So what's happening is we've got 215 times 1.005 to the number of 5% increases. And I want to think about like, because here we have t over 3, and this is going to get confusing, but I just want to think about like the simpler version for a second and say like, if this number is a 1, that's 1 5% increase. And if it's a 2, that's 2 5% increases. And if it's a 3, it's 3 5% increases, etc. Right? So if we had a situation where like instead of t over 3, it just said t, if we just had 215 times 1.005 to the t, then it would be pretty simple, right? If t is 1, that's 1 year, 1 5% increase. T is years, certain t years. If this just said t, it would be like every year that goes by is another 5% increase, right? Because this would be, if t is 1, it would be 1.005 to the 1. If t is 2, it's 1.005 to the 2, to the 3, to the 4, etc. Whatever t is, that's how many 5% increases there are. So if that were the situation, then the answer to how many months does it take would just be 12, because there's 12 months in a year. T is the number of years. How many months does it take to get to 1 year? Fucking 12 months to 1 year. Right? But that's not our actual question, because the question is a little bit harder than that. It's not t, it's t over 3. So the reality is that if we follow this through and see like how long does it take, and actually maybe we can like center our question around, or like center our work around this new question, which is like, how long does it take? Actually, you know what? This is the exact same question. How many months does it take to increase the population by 0.5%? And that's this. How long does it take to increase the population by 0.5%? That's taking this and taking it from 0 to 1, from 1 to 2, from 3 to 4. We're asking how many t, like how much does t have to go up in order to do that? Let's maybe just make a table, because when t, like here's what t is, here's what t over 3 is, and then we'll maybe say this is like the number of 5% increases, or sorry, 0.5%. Move all this over. This is like the number of times it goes up by 0.5%. When t is 0, t over 3 is 0, and it has gone up by 5% 0 times. So this is what's happening here. T is 0, 1.005 to the 0 is just 1, and we get 215 times 1, and we end up with 215. That's what happens at the beginning when 0 years have passed. Right? Well, when t is 1, remember in our easy version, t would just be 1, and that would mean it's another 5% increase. But that's not what happens in our equation, because t over 3 is 1 over 3, and we have not yet gotten to a full ass 0.5% increase. Really it's a third of a 5% increase, or actually a little bit less. But I just want to sort of demonstrate that t can be 1, and t over 3 has not reached 1 yet. T can be 2, and that's 2 over 3. And it's only when t is 3. It's only after 3 years, when t over 3 is 3 over 3, or like 1. It's only after 3 years that this number up here gets to actually 1, and we get 1 full 5% increase. From there, this is 1. Yay, we actually get a 5% increase. Because previously it's like, oh, we get like a third of a 5% increase, or we get 2/3 of a 5% increase, etc. This over 3 just slows the whole model down a lot. Anyway, all that is to say, how many months does it take to increase the population by 0.5%? Well, that happens every 3 years. Every 3 years that go by, 3 divided by 3 turns into 1, and we get another 5% increase. 3 years is 36 months, because there's 12 months in a year. And that's 36. And that's D. It's 14D. Yes, it is. Cool. So that was all like sort of like by way of long-winded explanation. I would say like the realistic way of actually doing this question 14 is the kind of question you should be able to do pretty quickly if you know how to do it. It's either sort of like you get it or you don't. Actually, I could see screwing around with these numbers, screwing around with this table and getting it. But the big things that are hard, I think, is not putting 3, right? Here at 3, this is the number of years instead of the number of months. That would be a solid way of screwing it up, just to like go through all of it right, and then at the very end put the wrong units. You need to remember that you're answering in months. That's why this is here. And then I think the other like parts that are hardest about it is just like not panicking when you see this happening, and actually just to play around with it and ask yourself, how does this affect the actual equation? What are the bones of what's happening here? Where is this 5% increase? And then what does t mean? Like as t goes up, how often is this 5% increase happening? Okay, question 15. Oh, strange. I'm looking at this and I'm like, I feel like all you have to do is just use algebra and simplify, right? And like that sounds like that's what you have to do. I don't even know if there's like a this is weird. Like I'm suspicious because it's like I feel like I would easily know how to do this question, but it's question 15, so like what the hell? So that's just me registering my, suspiciousness. But let's just do this. Actually, I guess there's a bunch of ways you can screw this up, but I'm going to expand this and then I'm going to subtract. I guess you need to distribute this negative sign. That's totally one way to screw this question up. And then combine the like terms and it's going to be one of these and then you win. So let's just spread this out. 2x minus 2 squared is 2x minus 2 times 2x minus 2. I guess that's like one way you could screw it up is to do like 2x squared minus 4 and to like think that you have successfully squared it. But we're not going to make that mistake. And then we're going to go minus, and I'm going to expand this. And here, I think, yeah, the expansion is going to be, you just need to not screw this up. We're going to go minus 2x. And then it's saying, instead of saying minus 2, we need to distribute this negative sign, so it's plus 2. I'm actually realizing there might be a big brain way of doing this, but I'm not sure if it's better. But I'll talk about it later. Let's just expand this now. First, outside, inside, last. Again, I don't do shortcuts because I always screw this up. But it's going to be 4x squared. That's the first. Outside is minus 4x. Nope, minus 4x. Negative 2 times 2. And then the middle is also going to be minus 4x. And then the last is going to be plus 4. And again, don't screw up this negative times negative is a positive thing. All right, and then it's minus 2x plus 2. And we're just going to combine the like terms. Maybe I'll just use some color coding here. Here's the x squared stuff. Looks like there's a lot of x stuff. Here's x stuff, x stuff, x stuff. And then there's just numbers, straight up numbers. There's this. So I'm going to do 4x squared. Minus 4, this is negative 8. Minus 2, this is negative 10. X. And then 4 plus 2, this is plus 6. Okay. We're getting there. Well, so first off, right at this point, I'm going to cross off B. Why am I crossing off B? Because B looks exactly the same as where I am, except it has the wrong frickin' number at the end. So there's no like situation where this is somehow equivalent to this, because the only difference is that we added 4 here. So B is wrong. So the question is like, how do I make this look more similar to these? I mean, there's an obvious next step, which is just to reduce all of this in here. So this is 2x squared minus 5x plus 3. And at this point, I'm getting a little bit suspicious of what's going on here because this looks, it's not like exactly like there's more than one difference, but it looks kind of like, I'm not going to totally cross this out, but it looks like sus. And let's see, so we're comparing C and D. This is, I guess, the part where it's getting hard because I feel like I'm using a lot of like advanced process of elimination stuff. But I'm looking at this and I'm thinking this is not, actually, yeah, I mean, this is definitely wrong. 2x squared minus 6x plus 6 is not the same. This is different, this is different, and this is wrong. So it's going to be one of these two. I mean, I guess actually you can just fully get there looking more closely at C by realizing like this answer choice C is the same. It's just this part. 2x minus 2 times 2x minus 2. It's this part. So there's just no way that like that this is the same thing as this thing minus some whole other thing, minus 2x plus 2. That's this adds a whole another element that makes it not the same. There's no situation where minus 2x plus 2, it changes nothing, which already that itself makes it wrong. But I mean, I guess honestly, if it's question 15 from there and I'm rushing, I would be like, that's good. Oh, sorry, that's good enough, and mark it, and be like, and just spend my time elsewhere. If I have time, come back to it and spend more time, you know. But I can just dive like further in a little bit. Oh yeah, I'll keep these. Then the question is like, is this the same thing as this? And for that, we have to kind of jump backward a step up from this and work with this version of the equation. And we're basically just asking, you know, are these the same? Are these equal? Because if they are equal, this is nice. And my way of checking this, instead of trying to factor this, which is a little harder, I'm just going to expand this and see if it matches. So again, we're going to do first 4x squared, good so far, right? Minus 6x, right, that's this. Oh, sorry, I did inside first. I'll do outside first. Minus 4x. Here's minus 6x. Here's plus 6. And cool, you know, that ends up matching. We got 4x squared minus 10x plus 6. And so that's D. Just to point out some like things I did to make this question easier. Big thing is I did a lot of bouncing back and forth between looking at answer choices and looking at where I was. I didn't finish all the way down and then start looking at the answer choices. From the get-go, I'm looking at answer choices and asking how it corresponds to the work that I was doing. Makes it so that you know, because this is a multiple choice question in the end, the right answer exists somewhere. And the wrong answers are going to be different in some way. I mean, B is maybe the best example. The wrong answer should appear somewhere as being different than what you're working on. You know, this 2 and this 6, it's different enough that you can then eliminate B. And like the more you eliminate answer choices, the easier, like the better and better the remaining answer choices are in terms of being clues, you know. D is like leaping out to us as being like, hey, like I'm probably the right answer. You should check me to see if I am the right answer. So that's maybe the big thing here. I wouldn't call question 15 the hardest question on this test by any means. So far, it kind of feels like 13 was the hardest, maybe 14. Yeah, 14, 13 kind of feels like the hardest to me for sure. All right, so that's 15. Anything else to say on 15? No, not really. Okay. So now we're going to go into the grid-in questions. And here I'm expecting question 16 to be easy. That's usually what happens. This whole section is a mix of easy, medium, and hard questions. And usually question 16, this first question, is an easy question. So 2s plus t equals 11. In the equation above, what is the value of s when t is -1? Okay, so well, we're just going to plug -1 in for t. So 2s minus 1 equals 11. Oh boy, 2s equals 10. Here we're, oh boy. We are adding 1 to both sides. So it's 12. 11 plus 1 is 12. It's not 10, it's 12. And then we're going to divide both sides by 2. That's s is 6. Is that the right answer? Yes. Great. Is there anything to say about 6? If you missed this question, slow the fuck down. If you missed this question, your attitude on question 16 should be, this is not multiple choice. I can't like count on the answer choices to correct me when I'm wrong. I need to slow the fuck down and get questions like this one right, because everyone should get this question right. All right, question 17. What is one possible solution to the equation above? I really like these one possible solution questions because it really means that like guessing and checking is dope, like it really works. But I'm not going to do it that way, partially just because I figure we can just expand the left side and then solve for x, and that'll probably work. So let's just do that. X minus 1 squared. Man, we've had to do this a lot, this test. But x minus 1 squared is this. This is x minus 1 squared. And again, so it's really not this. This is fucking wrong. That's not how you do it. You cannot do that. That's not how it works. You have to do this. So okay, x minus 1 times x minus 1, and then we've got 3x minus 5 over here. And then we're going to FOIL first outside, inside last. So we've got x squared minus 1x. So this is minus x. Here's minus 1x. I keep doing first inside, outside, but whatever. And then we're going to do plus 1. And that is 3x minus 5. We're going to combine terms. X squared minus 2x plus 1 equals 3x minus 5. And then we're going to, let's just move everything over to the left side and see if we can factor it. That's probably the play. We're going to make this equal 0. So we're going to subtract both sides by 3x. So we're going to go x squared, negative 2x minus 3x. This is minus 5x. And then add 6 to both sides because this is minus 5. Add 5 to both sides. Plus 5. Positive 1 plus 5, that's plus 6 equals 0. Well, this is like, I literally recognize it because of the number of times I've had to use this example. But this factors into x minus 2, x minus 3. Here again, because we're in the grid in section, it's like worth double checking to make sure you're not being stupid. Like, okay, like 2 plus 3, negative 2 plus negative 3, that's 5. Negative 2 times negative 3, that's positive 6, because the negative and the negatives are positive. Great. And then from here, our two solutions are going to be, we need to do the flippy signy thing, but our two solutions are going to be 2 and 3. Because 2 minus 2 turns this into a 0, which makes this true. And 3 minus 3 turns this into a 0, which makes it true. So 2 or 3 are the answers that work for this question. Am I right? I'm right. Great. 18. In the, let's see, is there something I want to say about this? Oh yeah, if you're struggling with doing this. First off, you should be pretty capable of doing this. If you aren't capable of doing these skills, you need to practice factoring and foiling. Not in Khan Academy SAT practice, but like, I like Wolfram Alpha. If you Google like Wolfram Alpha factoring foiling exercises, that's a pretty good place to learn this. This is a pretty simple factoring and foiling thing. You should, knowing those skills, you should be able to get this question. Alternatively though, if you're freaking out, you forgot how to factor and foil, guess and check a couple, you know. Here, this is, well, yeah, I'm not intentionally guess wrong, you know, so here's 5. We're going to go 5 minus 1 squared equals 3 times 5 minus 5, and be like, okay, 5 minus 1 squared, this is 16, equals 15 minus 5, this is 11. Ooh, that didn't work. Let's try a lower number, and then you hit it. Try a higher number, you'll be way further off. Try a lower number, you'll be like, oh, closer, closer, and then you'll try a number and it'll work. So a question like this with the what is one possible solution type prompt, this is the kind of question that if you don't get it up front, you can mark it and come back to it and plug in some possibilities and see if they work and get it right that way. All right, question 18. In the complex number system, what is the value of this expression? Oh boy. So here for a complex number, this is a complex numbers question. They only test a few concepts, but one of them is just like, you really should memorize the, like, well, I'll just explain how I is weird, but I is a weird number, and one of the ways in which it's weird is if you raise I, if you keep raising I to higher and higher and higher and higher powers, it goes through this like cycle. So I'm just going to show this to you right now. Rule about I. For one thing is they say, well, yeah, I'll get there. So normal I, it's the square root of -1. That's what they say here. Let's think about what I squared is. Well, I squared is the square root of it's the square root of -1 times the square root of -1. Well, that's fucking -1. You have to use this constantly. And in fact, actually, that's what we're going to do here. We're going to do this right here. We're going to take that I squared. I'm going to turn it into a -1, and this is going to be +8. Like, that's a thing. That shows up in almost all, not all, but almost all complex numbers questions. A second, another. Oh, headphone in. But we're not going to stop there because they also have an I of 4. And so we're just going to keep thinking about what happens to I as you move it to higher and higher powers. Here, I cubed is -1 times the square root of -1. That's what it is, because we're taking I times I times I, and here this is the times I part. Here's I squared, here's times I. And -1 is negative, so this is the square root, or negative square root of -1. That's what I to the third is. Well, I to the fourth is the negative square root of -1 times times the square root of -1. Well, this is frickin' -1. So what we have is negative the -1, which is just frickin' 1. And then get hype. Well, that's actually, so this is enough to do this question. The way to do this question, if you want to skip forward, is like this is -1, this is 1, add them up. But just to note, I to the fifth is back, we're back looped around to the square root of -1. And so the thing, and then it just like goes on, because so it's 1 times the square root of -1. It just like freaking snowballs from there. I to the fifth is the same as I, and I to the second is the same as I to the sixth, and it's just like every 4 powers, it just repeats itself. But okay, we don't need to go all the way down that ridiculous rabbit hole, because all we need for this question, and trust me, even if you didn't remember that rule, you can do what I just did and work it out for yourself, knowing that I is the square root of -1. Just figure out what I squared is. It's -1, and work from there, just like get up to 4. But there are other reasons why you should memorize this that I won't go into now because this question doesn't require it. But so from here, it's just 16 times 1, because I to the fourth is 1, minus 8 times -1, because I squared is -1, plus 4. So that's 16 plus 8 plus 4. And now we're just going to we really just need to not fuck this up. I'm just going to play it. So this is 12. 16 plus 12. This is an 8. Oh, we're gonna not even do this in my head, you know? We're so close to getting this point, you know? Mental math is going to mess me up. This is 8. This is 2. It's 28. 28 is the answer. This is where like I'm just so suspicious of myself. I've missed so many points just doing some dumb shit. Double check this, you know, and make sure before I put 28. Is 28 the answer? Yes, it is. All right, cool. Yeah, I'll say complex numbers, this particular question type, all questions about complex numbers, is one of the more learnable ones just through doing Khan Academy questions. Khan Academy is really good at, they only ask basically 3 different kinds of complex number questions, and they all focus around like a really small number of rules. There's like 3 total rules that are new that you need to memorize. One of them is this. The other one is about like how to multiply them and how to subtract and add them. But it's just so, it really is very simple and learnable through Khan Academy. So if you find yourself missing a bunch of complex number questions, I mean, there's like, you know, between 1 and 3 every test. If you're losing points there, just drill a ton on Khan Academy, and like you'll pick up some stable points from problems like this. All right, penultimate problem. We're almost done. Question 19. The table above, this table, shows 2 pairs of values for the linear function f. We just have 2 points, hopefully on a line. Oh, it is on a line because it's a linear function. 2 points on a line. The function can be written in the form f of x equals ax plus b, where a and b are constants. What is the value of a plus b? This is just asking us, what is the equation of the line? And actually, maybe I'll put it this way. They often do this where instead of just saying, hey, what's the slope of the line? Also, what's the y-intercept of the line? Hey, could you take those and add them together? Instead, they talk about how like theoretically you could write it in this form where a and b are constants, and then they ask you to do stuff with the constants. It is confusingly worded, but all they're using these constants for, these quote unquote constants, a and b, like they're not introducing new variables. They're just using these letters as a way of pointing at a certain part of the equation, you know? So like b, this is just the y-intercept. That's what b is. It's this. It's the y-intercept. Theoretically, you could write this function in the form y equals mx plus b. You could write it in slope-intercept form, where b is the y-intercept type thing. And then similarly with a, a is just the fucking slope. So literally all they're asking you to do is, like, what they're asking you in English to do is to find the equation of the line. What is the slope? What's the y-intercept? And then take the slope, take the y-intercept, and add them to each other. And like, I think maybe in part because they feel like it's cleaner to ask it in this way, and then surely in part because they know it's more confusing to people to ask it this way. They put it this way instead, where they say, hey, you could theoretically introduce these two concepts. If you did introduce these two concepts and then add them together, what would the answer be, right? And you just need to not get tripped up when they're introducing constants, and instead just to be like, what part of the equation are they pointing to here? This one points to this. This points to this. Okay, so with that said, we're just going to find the equation of this line. Let's find the slope first. We're going to find the slope with this. Well, the slope is rise over run. So rise over run. This is rise. This is run. This goes plus 5. Between these 2 points is going to go up 5. Over here, this is going to go up 4. So the slope, Jesus, that's terrible, terrible writing. Slope is 5 over 4. And again, this is a grid-in question. We don't have multiple choice to like correct our idiocy. So I'm just going to make sure that I'm not dumb. We went from the point, so here's x coordinates, y coordinates. We went from 12 to 17, that's 5. We went up 5. And then from 8 to 12, we went up 4. Rise over run, we didn't screw it up and go 4 over 5. We're doing rise over run, it's 5 over 4. So A, our slope, A is 5 over 4. Now the question is, what's the y-intercept? There's a couple different ways of doing this. You could probably even, I bet that graphing it would be annoying and stupid. I'm just going to plug, because now that we know A, I'm just going to plug one of these points into the equation and solve for B. It's probably the most simple way. It's probably the way they like intend you to do it. So here we're going to solve for B. I'm just going to use this point, the 8 and the 12. So I'll just write this all out for simplicity. So it's easy to follow. F of x equals ax plus b. And I'm just going to plug in 12 for f of x. I'm going to plug in 5 over 4 for a. I'm going to plug in 8 for x. And then we're going to solve for b. Well, okay, so 5 over 4 times 8, that's 40 over 4. Why? Well, because 5 over 4 times 8 over 1. We're just going to multiply straight across. It's 40 over 4. And just right now, 40 over 4 is 10. Right? 40 divided by 4, that's 10. Let's be simple. Plus b. And this is 12. All right, well, 12 minus 10 is 2. And that's b. So b is 2. Great. All right, so what we have here is 5 plus 4. Or sorry, 5 over 4 plus 2, because we need to do a plus b. A plus b equals 5 over 4 plus 2 equals what? Well, we need to figure out how many fourths 2 is. We need to make this common denominator. So 2 is 8 over 4. So it's going to be 13 fourths. That's how many fourths it is. It's 13 fourths. And this is usually the part where I'm going to double check my answer again, partially because like this was easy enough or like straightforward enough that like I'm not likely to come back to it. You know, it wasn't super confusing. And so if I made any mistakes here, I probably wouldn't catch them. So we already did enough double checking of this, so I think that's okay. Let's just double check that I did this math right. 504 times 8. Did 8 make sense? Yeah. 8 times 5, that's 40. 40 divided by 4 is 10. Yeah. 12 minus 10 is 2. Blah, blah, blah. Yeah, 2 is 8 fourths. This is good. So 13 over 4. Is that the answer? Yes. Good. Okay. Question 20. Home stretch. Oh, God. And then am I really going to go back to that stupid question that I missed? I'm going to do it. Okay. Question 20. Segments OA and OB, these segments, this one and this one, are the radii of the semicircle above. This is a semicircle and they are some radii of the semicircle above. Arc AB, this arc, has the length 3 pi. That's how long this is. Great. And OA, the length, the radius is 5. Okay. What's the angle? What's the value of x? Oh, let's see how to think about this. I'm actually pretty rusty on this. I haven't done a problem like this in a long time. But the way to think about it is, well, what is the circumference of a circle? The circumference of the circle all the way around the... Oh, yeah, we actually, if you don't remember this, the formula is at the beginning of the section, but the circumference of the circle is 2 pi r. It's 2 pi times the radius. That's how long the circumference of the circle is. And then the idea is that the relationship between the arc and the whole ass circumference is the same as the relationship between the little angle, which I'll just say x. And in this case, because x is in degrees, and 360 degrees. And this is how we're going to solve this problem. Which is all to say that, that 3, if this arc is 3 pi, whatever, there's no units, let's just say feet long, so this is 3 pi long. The percentage of the whole circle that the circumference is, that this 3 pi part of the circumference is, that's the same percentage as the angle is a percentage of the whole angle. So maybe easiest to understand in terms of just with the example of the half circle or whatever. Oh, and I guess I maybe could just do it to 180 and the half circumference, but fuck that. Just imagine a whole ass pizza, right? This is a pizza. There's no way of getting a cut with straight lines that starts here and ends here. We're cutting a quarter of the crust of the pizza, this fourth of the pizza. When you cut a fourth of the pizza in terms of the perimeter of the pizza, the crust, what you're also doing is ending up cutting a quarter of that central angle. You're going to be cutting a right angle amount of pizza and taking that whole quadrant of pizza. So that's the idea here, is that if you're taking a quarter of the circumference, you're taking a quarter of the angle. And the same thing works with area. If you're taking a quarter of the area of the pizza, you're also taking a quarter of the angle. So that's how we set up this particular equation, is that we know what the circumference is. We know that the equation for the circumference is 2 pi r. We have the radius, which is nice. And we have how long the arc is. And so the relationship between our arc, which is 3 pi, and the whole circumference, which we're going to be able to figure out, is the same as the relationship between x, which is the angle we need to find, and 360, which is the whole last way around. Probably it's slightly easier to, or I don't even know if it's easier. They might just be counting on you being caught off by the fact that this is a semicircle and freaking out about maybe we should use 180 and half of this. You could if you wanted to, but ultimately the principles are the same. Just these proportions are the same. Part of the arc is part of the circumference. This part of the angle is part of the whole way around. So we're just going to execute on this. I'll turn this actually into light blue. Whoa. Light blue. move it up here because this is more like a rule than anything else. And again, you can look this up. Actually, let's just do this for fun. All the way up at the top. Here is the beginning of the test. It's on this page right here. It's this. Circumference equals 2 pi r right here. Okay. So we're going down. Here's question 20. Let's just solve for the circumference first. This feels like it makes sense. I'll just use the same number. Well, the circumference equals 2 pi r. So the circumference equals 2 pi times 5, because 5 is the radius. The radius is, yeah, how do we know that? Okay, because OA is 5, this is 5. Separately, they say OI is a radius, so the radius is 5. So the circumference is 10 pi. It's 2 times 5 times pi. And now we're going to start plugging stuff into this main equation. So here, I'm going to take this, and we're going to do a bunch of substitutions. The arc is going to be, let's see if I can zoom in a little. Maybe not. Yeah, maybe not. The arc is this. This is how long the arc is. That's 3 pi. The whole ass circle, the circumference of the whole ass circle, well, that's 10 pi, which we just found here. That's going to be the same as x, which is the thing we need, over 360. Well, first off, I'm going to cancel these pi's. So we got 3 over 10 is x over 360. And then from here, we can cross multiply. So I'm going to do the 3 times 360 first. I just know this because of snowboarding. If you do one 360, that's a 360. If you do another 360, that's a 720. If you do another 360, that's a 1080. And then this is equal to 10x. I mean, you could also do math, 360 times 3, blah, blah, blah. You'll get 1080. But the idea, right, we're cross multiplying. This times this is this times that. All right, well, 1080 equals 10x. Well, we're just going to divide both sides by 10, and we're going to get 108 equals x. That should be the answer. We're going to write that in. Is it the right answer? Yes. Great. Yeah, I would say that for these types of questions, which for reference, this is a circle theorems question. This is another, like, they're kind of rare. I wouldn't say they're that rare, but like there's usually like 2 max per SAT. And they kind of like complex numbers questions. They test a very particular, like, actually I won't block this. But I wanted to show this, like this complex numbers question. Kind of like complex numbers questions, they tend to test like predictable, like a sort of small number of predictable rules. So, it's pretty likely that if you got this question wrong, it's because you just aren't super familiar with this way of solving problems like this, and you shouldn't really feel bad about it if you haven't learned it yet, or if you like are rusty on it. Just go back to Khan Academy and do a bunch of circle theorems questions and have an eye toward just learning the rules. Okay, in situations like this, you set it up like this and then you do it. I would call these pretty like high on the how easily can I learn this myself list, even though they're kind of low on the how often do they come up list. All right, here's where you can stop if you want, but goddamn, I am just going to return back to this freaking question. Which one is it? Oh, Mike's idiocy. And we're just going to do this. We're going to see what was wrong with this. I'm so stupid. All right. 10. In the equation above, c is a constant. C is a constant. If the equation has infinitely many solutions, what is the value of c? And I was like, it needs to end up being x equals x. And in order for it to end up being x equals x, this needs to be That needs to be negative 7x. This needs to be negative 7x. This needs to be 7x, but god damn it. Did I fuck that up? Is that what I did? Yeah, this doesn't need to be 7x. This needs to be fucking negative 7x. Yeah, because if this turns out to be 7x, oh, Jesus Christ, I'm so dumb. All right, so that's very easy. So like, this ultimately is definitely a dumb way of doing it. Like, this way is a better way of doing it. But as I suspected, I just made a very small little arithmetic error. I was thinking about this wrong. I was thinking that again, just sort of back up. I was thinking, in order to have infinitely many solutions, we want to set this equation up so that it sounds like something that's just true, like x equals x. And so I was like, okay, let's set this equation up so that it says x equals x. Well, okay, we're starting with 8x. Let's set the equation up so that this turns out to be 7x, Or, well, God. So this turns out to be 7x. Because if that is 7x, then we'll get 8x minus 7x is 1x, and x equals x. It's great. And from there, we should be able to do this. I should be able to say, I'll just do this tiny, 2x times c plus 1 equals 7x. We're going to go 2xc plus 2x equals 7x. We're going to subtract frickin' 2x from both sides. So it's going to be 2xc equals 5x, and then we're going to do the x's, go the x's, c, the x's cancel, c equals 5, 2c equals 5, c equals 5 over 2, we get the right answer. So, like, I kind of, from the get-go, I sort of, like, overly big-brained it. My logic was right, in thinking, like, yeah, we need to set it up this way. I screwed myself over because I forgot about this negative sign, and I tried to make this whole big block equal 7x, which is dumb and bad. Overall, I would recommend, I just sort of got lost in the weeds. But actually, the big thing, the reason why I wanted to, like, bang my head against it previously and then demonstrate what it looks like to mark it and then come back later is to show you, like, this is a genuine example of, like, you watched me fuck that question up the first time around. You then watched me, like, while I was still doing that question, completely fail to see what I did wrong. I was looking at it, I couldn't figure out what the fuck I did wrong. I was like, what the hell, right? And the only thing that changed between the last time I was looking at this problem and this time, when I caught it super quick, is that I let time pass. I allowed a bunch of time to go by. I marked this question as the kind of thing that, for whatever reason, I don't understand what's happening right now. I changed my focus. I looked at a whole bunch of other random shit. A bunch of time went by. And then I came back with a fresh set of eyes, thought about it from the beginning. And, like, as soon as I got to a place where my work I didn't recognize my work, it's like, oh, I'm doing the same thing. I'm thinking the same thing. I'm thinking the same thing. Oh, I'm thinking about it differently now. Then I asked myself, is that the thing I fucked up? And the answer is yes. And then from there, you can be like, cool, I'm going to do the problem right now. The actual, like, I would say, like, the applicability of that lesson, the reason why I think it's an important thing to show and to demonstrate to people is that this will happen on the SAT. It will happen live to you. That's a thing that happens. You saw it happen to me. I get 1600s on SATs, and it happens to me. It happened here. The response is to do what I did. You're going through a question. If you realize you've made a mistake, spend a little bit of time trying to debug, but accept the chance that it's likely that the reason why you made some mistake is some blind spot that you have, some dead angle that you have, that you aren't going to be able to see right now. And then respond to that instead of just, like, spending a million years just, like, staying and staying and staying. Recognize that you could better spend that time after you've had the chance to change your focus and come back. This is true on the individual test. When on a question like this, you should skip it,
do the rest of the stuff and then come back with your extra time, you're more likely to catch your mistake and get it right. This is also true after you get the results of practice tests back. You know, there's a chance you miss this, you come back to it, you still don't get it. There's a high chance that after you get your test results back, you realize you got this question wrong. You're looking at this question in hindsight, you get it right. Take the time to do it. It's important, it's really valuable, and it makes you less likely to make the kind of mistakes, like these exact kind of mistakes again in the future. Here, my specific mistake that I made was forgetting this negative sign. And this is you probably heard my little comments about it all the way throughout this section, how many times I like was really careful to try to not screw up negative signs. It's because even now, I still fuck it up sometimes. It's just this is one of my weak points. It's one of the more common weak points, but it for sure is one of my weak points. So you'll see me in later ones as I'm going through, I'm gonna be like extra salty about negative signs and really caring about catching them. Okay, cool. As I mentioned earlier, okay, so this is all the whole ass SAT 13 test. If you have questions, drop them in the comments. If you have feedback, critical feedback, or things I did well, or things you want to see more of, leave them in the comments. Hit me up. I hope this was useful, and I'll see you all next time.